Hi! In this tutorial, I'm going to show you how to create a game using the AIR SDK and the Starling Framework. If you're new to AIR SDK, I would definitely recommend checking out our previous tutorial. In that video, you'll learn how to download and install the AIR SDK and how to set up a new ActionScript project in VS Code. You'll find the link to that tutorial in the description below. Also, if you are absolutely new to ActionScript 3 programming, then I'm afraid this might not be the right place for you to start with, because throughout the tutorial, I'm going to assume you have an intermediate level understanding of ActionScript 3, which means you should be familiar with the Flash display list, as Starling bases its API on that, and also be comfortable with object-oriented programming techniques. We will be creating things like classes and interfaces, so you should have a good understanding of what those are. If you have built Flash games before, then wonderful. This tutorial is going to help you a lot. Alright, let's start by creating a new folder on the desktop and name it TurboShift. Yes, that's the name of the game we'll be building in this tutorial. Now let's open it up in VS Code. Let's add a new folder to the project directory and name it SRC. I have named the main class as TurboShift. Next, we need to choose the AIR SDK for this project. I am going to select the latest version available on my PC. We need to add the ASConfig file. Without it, Code Intelligence might not work. I am going to copy-paste the same template that we used in our previous tutorial. We need to make few changes in this configuration. First, let's change the main class to TurboShift. Next, let's rename the application descriptor XML. We also have to add this XML to our project, which we will do in a minute. Next, I am going to change the configuration from AIR Mobile to an AIR. That's because, for this tutorial, we will be focusing only on the desktop platform. And finally, let's rename the output file. I will be making more updates to this file as we progress through the tutorial. Let's now add the app XML in the SRC folder. Let me copy-paste the app XML template. We need to make some changes here as well. The current SDK version is 51.1. Feel free to set the ID and version number to something of your choice. Changing both file name and app name to TurboShift. Next, let's create our main class. We need to extend it with Sprite class, which will be flash.display.sprite. Let's add a trace statement to its constructor. Before we can test the build, we need to add the configuration for SWF. We need to add a pre-launch task to read the ASConfig file. Now let's start debugging. And you can see the message, Hello TurboShift, in the debug console. Next, let's download the Starling Framework and add it to our project. Open your browser and head over to gamua.com. So, what is Starling? Starling is an open-source framework, fully written in ActionScript 3. It's mostly used for building 2D games. Starling is actually built on top of Stage 3D, which means now we can fully tap into the power of the GPU, resulting in faster rendering, better performance, and awesome games. If you'd like to learn more about the framework and its features, definitely check out their website. You can download the latest version from the Downloads page or visit their GitHub repository. For this tutorial, I am going to download it from their GitHub repository. Once the download is complete, extract the zip file. Then open the folders and locate the Starling directory. Inside it, you will find a folder named SRC, which contains the source code of the Starling framework. I'm going to copy these two folders. Then navigate to the TurboShift folder. Let's create a new folder and rename it to code and paste them into it. This code folder is going to contain the source files of all the frameworks that we will be linking with our project. We will be adding more to it as we go along. Next, we need to include this code folder in the AsConfig file. This way, we can keep our project directory neatly organized, with the src folder containing just the game code. Okay, now we are all set to add Starling to our project. Open the main class. First, let's add the Swift metadata. Our game is going to be 640 pixels wide and 960 pixels tall. We'll set the frame rate to 60 frames per second, thanks to the GPU. And I'm going to set the background color to black. Next, we need to initialize the Starling framework. To do that, let's first declare a private variable, Starling, of type Starling, and then initialize it inside the constructor. The first parameter of the Starling constructor is a class that will serve as the root of our Starling display hierarchy. We'll create that class in a minute. Let's go ahead and name it Game. Then, for the second parameter, we pass the stage from our root Swift, so Starling knows exactly where to render everything. The next thing we need to do is start the Starling instance. Yes, we can actually start and stop Starling. This comes handy when the user minimizes our game. We can detect that and stop the instance. And when they return, simply restart it. So basically, this creates the root instance of our game class, and the start method simply kicks off the Starling rendering process. So let's go ahead and create that game class. Make sure to extend the game class with starling.display.sprite and not by flash.display.sprite. Since we're now in the Starling world, it runs separately from the regular flash.display package. Inside the constructor, let's add a trace statement. This will print a message in the debug console as soon as the root display object is created. Let's now run the code and see that in action. When you run the code for the first time, you might see an error, context 3D not available. That's because we haven't set the render mode in the application descriptor XML. To fix this, open the app XML and simply add the render mode node, with its value set to direct. This tells AIR SDK to use the GPU for rendering, which is necessary for Starling to work properly. One of the cool features of the Starling framework is its built-in stats class. We can easily enable it by setting the show stats property of the Starling instance to true. While debugging, this can be really helpful. It shows the current frame rate, the amount of memory used by ActionScript objects, the GPU memory usage, and the number of draw calls being sent to the GPU for each frame. Before we move any further with Starling Framework, let me quickly introduce you to Starling Builder. It's an open-source UI editor built on top of Starling and Feathers UI. It allows you to create any game UI within minutes. Starling Builder has two parts. First, there's the editor, where we design the user interface and save it in JSON files. And second, there's the engine. That part reads those JSON files, converts them into Starling display objects, and adds them into our game. It's designed in such a way that what you see is what you get. You can download both the editor and the engine code from the Starling Builder's website. But for this tutorial, I would recommend that you download it from my GitHub page, as I've made a few adjustments to both the editor and the engine code. You can find all the links mentioned in this tutorial in the description below. Let's first download the Starling Builder engine code. Unzip the package. Then, copy the Starling Builder folder and paste it right into our project's code folder. Next, let's download the Starling Builder editor and install it on our system. If you haven't installed the AIR runtime on your system, please download it from the official AIR SDK website. Click on AIR Runtimes, then choose the appropriate download for your platform. When you open Starling Builder for the first time, it'll prompt you to choose a folder as a workspace. The workspace should be a place where you'll store your assets, extensions, and settings related to the editor. Let's navigate to our project, Turbo Shift, and inside it, create a new folder named Assets, and choose that as our workspace. Reopen the editor, and now if you check the Assets folder, you'll see that Starling Builder has already organized some directories neatly for us to get started. By default, the editor reads assets from the textures folder. Before we start working on the assets, let's quickly download Feathers UI and add it to our project. Feathers UI provides a large library of user interface components for the Starling framework. The Starling Builder editor itself is a great example. It's fully designed using Feathers UI. The buttons, the labels, the progress bars, the drop-downs, and so on. Feathers also supports robust skinning APIs, which means you can change the appearance of Feathers components to match the exact style you have in mind. Since we're building a game, we won't be using many Feathers UI components, except for the list component, which we will use to display leaderboards. However, Feathers also provides several layout classes, and we will be using those extensively in our project while designing the layouts. Also, we won't be using any skins in this project, so the skinning part won't be covered in this tutorial. Let's download Feathers UI from their GitHub page. Then, copy the Feathers folder from its source directory and add it to our code directory. All right. Let's now jump into the Assets folder and take a look around to understand what's what. Or, you know what? Instead of giving a walkthrough of the assets right now, how about I show you the final game we're building in this tutorial? Sounds good? It's a simple top-down 2D game. All you have to do is just tap anywhere on the screen to shift lanes and avoid collisions with other cars. The smoke from the exhaust, the blast when there's a collision, and the engine catching fire are all created using particle effects. Did you notice something? I was actually playing the game in a browser. But how? To know more about it, watch till the end of this tutorial. It's really easy. Coming back to our Art Assets folder, these are all just individual PNG files. But we don't have to load them one by one in the game. Instead, we can pack them all into a single texture atlas using a TexturePacker tool. There are many texture packing tools available, but for this tutorial, I'm going to use this free TexturePacker. Let's download and install it. click on Add Images. Or, if you want, you can also drag and drop images here. Let's select them all and click Open. You can see that only the images from that folder were added. There was a folder with the bird's animation sequence, which is missing. To add that, click on Add Folder, and then select the folder. If you want to see the bird animation, just select the folder and then click on Animations. Next, we need to configure the texture packer for our Starling project. We will keep the texture name as texture itself. We need to select Remove File Extension. Otherwise, when referring to images, we will have to include PNG along with it. Also, uncheck Prepend Folder Name. That's only required if you are using same image names across multiple folders. Change the format to Starling. Next, we need to choose the folder where the texture atlas and the XML file should be, exported and saved. Let's select our project folder, Turbo Shift, then open the Assets folder, and then select the Textures folder. This is essential, otherwise, Starling Builder won't be able to access these files. Let's keep the size as it is. We will increase the padding to 2. It's a good practice to avoid visual glitches. Uncheck Allow Rotation and Allow Trim. We won't be needing those for this project. And finally, let's change the packer to Optimal Packer for better packing efficiency. Now, let's click on Export and check the Textures folder. You can see 2 files, Texture PNG and Texture XML. The Texture PNG file is the sprite sheet, and the Texture XML file contains the texture atlas. To use a texture from the sprite sheet, simply refer to its name as defined in the XML. This is the data for the bird animation. Next, we will save this project setup. That way, we can come back and edit it anytime. I already have a file saved in the same location, so I'm just replacing it. Let's open the Starling Builder editor and check if everything is working fine. Click on the Asset tab, and there you go. Starling Builder read the texture atlas from the Textures folder and automatically extracted all the individual PNG files into the editor. Now, we can simply drag and drop these assets onto the canvas. Next, let me explain how to use the Starling Builder editor. First, go to the File menu and select Settings. Now, every layout in Starling Builder needs a root class, and you can set it either as a sprite or as a layout group. I will show you the difference between them in a minute. Next, you'll need to set the canvas width and height. By default, it's 640 by 960. If you want to switch to a landscape mode, say 1280 by 720, just update the dimensions and create a new layout. The canvas will now reflect the new size. Let's discard that for now and switch it back to 640 by 960. We'll skip the remaining settings for now and leave them as they are. Now, let me show you the difference between a Starling sprite and a Feathers layout group. For this layout, we have kept the root class as sprite, and below here, you can see its properties. Now, let's add a new sprite into it, and inside it, let's add an image of the settings icon. I'm going to position the sprite at the top right corner of the screen. We can adjust its XY properties here. Now, let's test how this layout would look on an actual device with a stage size of 640 by 960. Everything looks good, but there's one problem. When the canvas resizes, the sprite class doesn't automatically update the positions of its children. This makes it pretty tricky, and we'll need to write additional code to reposition each element whenever the canvas resizes. This is where the Feathers layout group steps in. It comes with a built-in layout system that automatically adjusts the position of its children, making it super easy to build responsive UI layouts. Let me show you how layout group works. In the settings pop-up, let's go ahead and change the root class to layout group. Discard the changes and create a new layout. You will notice that the root is now a layout group, and the Properties section has been updated as well. In the Properties section, you'll see a layout property. Let's go ahead and set it straight away to Anchor Layout. This is important because Anchor Layout allows us to anchor child components to the edges or center of the layout group. Rather than manually setting the XY positions, we can use constraints like top, bottom, left and right, or horizontal and vertical center to position the children easily. Before we start adding any children, let's set the layout data for this layout group. Since we've set the layout to Anchor Layout, we'll need to pass in Anchor Layout data. Now, this step is optional, but we're using it to set a specific size for the layout group. We'll set the % width and % height to 100, which means our root layout group will always take up 100% of width and height of its parent container, in this case, the canvas. By default, you'll see that the width and height are both set to 0, but as soon as we set the property, they'll change to 640 by 960. Now, let's add a child container to it, which should also be a layout group. Then, inside it, let's add the same settings icon image. Now, select the child layout group and set its layout data as Anchor Layout data. Now, set its top property to 5, which means its Y value will be 5 pixels away from the top of the parent container. And set the right to 5 as well, which means its X value will be 5 pixels away from the right side of the parent container. You will notice that as soon as we set the values, it automatically repositioned to the top right of the root layout group. Let's go ahead and test this layout. As the canvas width changes, the layout group containing the settings icon automatically stays positioned at the top right of the root layout group. Let's rename the layout group to Top Right Layout and set its layout property to Vertical Layout. Let's keep the default values as it is and add more icon images into it. You can see that as we keep adding new children to it, the layout automatically arranges its children vertically one below the other. Let's now try tweaking its layout properties. As we increase the gap value, you'll notice it adds more spacing between each child. Similarly, we can also adjust the padding values. Next, let's set a background skin for this layout. You can either use a quad or an image as the background skin. Let's first try with a quad and see how it looks. Let's also give a color other than white. Next, let's try an image instead. The texture did not load properly. This can happen sometimes with the editor. Just select something else in the layout list, and then select the top right layout again. See, now it loaded. Let's increase the width of the layout to 90. To do that, first check the explicit checkbox and then set the width value to 90. Same goes for the height. Just check the explicit box and set the value. Looks like the layout's alignment is currently set to top left. Let's fix it. I will change the alignment to center and middle. All right, now let me show you how to center a layout group inside its parent container. First, select the root layout group and add a new layout child to it. Go to the Common tab and choose Layout Group. Let's rename it to Center Layout and add our game's title image to it. Now select the center layout, go to its layout data, and assign an anchor layout data. Then, set both horizontal center and vertical center values to 0. Now, let's test the layout. You can see that, regardless of the canvas size, the center layout always stays at the center, and the top right layout always remains at the top right of the root layout. Finally, let me show you one more feature related to the background skin of a layout group. Select the root layout, then click the Edit button next to its background skin property. From the drop-down, choose Image. Then click the Edit button for the Texture property and select the tile texture. Click OK. Again, the image didn't load properly. This is actually a known issue with Starling Builder. Sometimes, when you chain multiple changes in the same property window, the editor might not respond, and you'll have to force close it, losing all your unsaved changes. The only workaround to this issue is, while changing properties in a layout group, avoid chaining changes, especially when textures are involved. Make sure the textures are properly loaded before making any changes that affect them. To fix this issue like we did earlier, just select something else in the layout list, and then select the root layout again. Click the Edit button of the background skin property once more, and this time click the Edit button for its tile grid property. From the drop-down, choose Rectangle. You'll already notice the change in the root layout. Now click OK. Again, click OK. And now, test the layout. You can again see that, regardless of the canvas size, the background always gets filled with the tile texture. Next, let me quickly show you a few basic features of Starling Builder. Let's start with how to create a Starling button. At the bottom, you can see an option, Starling Display Image. Click on it, and then select Starling Display Button. Now any image you select from the asset list will be considered as a Starling button by the editor. Let's try that with button_normal texture. Now, let's change it back to image and then select the texture button_gray. You can see that button_gray is an image, and button_normal is a Starling button. Let's test the layout and check. Button_normal is clickable and button_gray is static. The button class has additional parameters, and let's check them quickly. We can add text to the button. Now let's format it. font used here is a system font. You can change the size and set a color. Next is the Scale 9 grid, and after that it's upstate and downstate. Okay, let me explain that using another button texture. To add a button, we must first change the option back to button, and then select button underscore up. So the upstate is the button underscore up texture. Now, we need to add the downstate texture. That will be button underscore down. See? When I increased the button size, the button underscore up texture got stretched. Let's apply Scale 9 grid to it. The texture will now only stretch from the center portion, keeping the corners intact. Because we are using downstate, we can set the scale when down value to 1. Or, let's keep it at 0.98. That should give the button a nice pressed effect. Let's now test it. You can clearly see the downstate texture in action. Before we move on to Movie Clip, I just wanted to point out that the font that we used for the button was a system font. The other font we have is the mini font, which comes default with Starling Framework, and it's used to display the stats here. For the game that we are building, we will be using a bitmap font and won't be using any other kinds of fonts. Next, let me show you how to use Movie Clip in Starling Builder. If you are coming from the traditional Flash game development background, then you will notice there are no timelines for movie clips in Starling. Instead, we have textures. You can create movie clips in Flash, or nowadays it's Adobe Animate. But you have to export them in PNG sequences and create a sprite sheet out of it. We have already done that with the bird animation, and it's already included in our texture atlas. To create a movie clip in Starling Builder, go to the Common tab. Then, select Starling Display Movie Clip. Just click on the Prefix Input option, and you can see the texture names in the dropdown. Select any texture starting with bird underscore. The digits after the underscore represent the frame number of the animation sequence. Let's remove the digits and keep the prefix as bird underscore. Click OK to add the movie clip onto the canvas. In the Properties section, you can click the play button to see the movie clip in action. We can also change its FPS. Next, let's create our bitmap font. For this, we require a TrueType font, and I have already downloaded one for this tutorial. Next, we need a bitmap font generator. There are many apps available for it, but for this tutorial, I am going to use an online bitmap font generator, Snow Bitmap Font. First, let's add the downloaded font to it. Let's remove all these unwanted symbols from the glyphs. Let's keep a few, just in case. Next, let's set the font size to 40. Padding? Let's increase it to 2. spacing, you can leave it at 1. We need to change the font color to white. Let's enable stroke and keep its width at 1. We can also preview the font here. Next, we need to export it. We will keep the font name as it is. Let's keep the same name for file name as well. For export type, select the one with font extension that creates an output of XML. Click Save. It should create a zip file and automatically download it. Let's save this font configuration. Just double-click here and give it a name. And then click Save. Let's unzip the bitmap font. Similar to our texture atlas, we have a sprite sheet and an XML file here, this one with a font extension. I am going to copy both the bitmap font folder and the bitmap font configuration to the project files folder. Next, open the bitmap font folder and copy these two files. Go to our project folder. Open the assets folder. Then, textures folder and paste it there. If you make any changes to the textures folder, Starling Builder will require a reload to fetch the latest updates. So, let's reload the editor. Now, you can see the bitmap font is loaded, and you can simply add a text field by clicking on it. You can format it in the Properties panel. Similarly, you can add bitmap font to buttons as well. If you click on the font section, it will show you the list of available fonts. Just pick our bitmap font, change the size to 40, change the color to white. So, that's it for the introduction to Starling Builder. We will come back to it shortly for designing the UI layouts required for our game. Next, let's get back to VS Code. So to catch up, We just created the game class, and the first thing we need to do now is to load our game's assets. That is the texture atlas and the bitmap font. So let me now introduce you to the Asset Manager. It's a very nice helper class that comes with the Starling framework. We can stuff all kinds of game assets like textures, sounds, fonts, etc. into it and access them just by their names. So let's first create a public variable for the Asset Manager and initialize it in the constructor. Next, we need to enqueue the assets and pass all the assets path into the array. You already know that we have placed our texture atlas and bitmap font in the texture folder, which is inside the assets folder. So its path will be assets/textures/texture.png. Remember, the texture atlas consists of two files. One is the PNG and the other is its data, which is an XML file. So we have to include both, and the Asset Manager will take care of the rest. Similarly, we have to do the same for the bitmap font, which again has two files, the PNG file and the font file. Next, we need to load this queue. To the load queue function, we need to pass a function which will be called when all assets have been loaded. First, let's create that function. We will call it onComplete. Additionally, we can also pass two more functions which are optional. One will be the onError function, which will get called whenever an error occurs while loading the assets, and the other one would be onProgress. This function will be called during the asset loading process and can be used to display the progress. Let's pass them as parameters. OnComplete will be called only once. On the other hand, onError and onProgress may be called multiple times. Next, we need to include the assets folder along with the package. Otherwise, the path mentioned in the Asset Manager's enqueue function will not work. So, in the asconfig file, let's add AIR options. Inside it, files. The file property refers to the location of a file or folder on your computer's local file system. And the path property is the directory where it will be added to the application package. Now let's debug the build. Let's check the debug console. You can see that all the mentioned assets were loaded and no errors were thrown. Next, we are going to work on states. Our game is going to have two states, the lobby state and the race state. And we will be handling these states in the game class itself. To define these two states, we need an interface. Let's first create that interface and name it iState, and add two functions, update and destroy. The update function takes a parameter called timePassed, which represents the time elapsed, commonly used in game loops to control animations, movement, or timed actions. This allows any implementing class to adjust its behavior based on time. The destroy function takes no parameters and is typically used to clean up resources or remove objects when they're no longer needed. In the game class, let's create a public variable, current state of type iState. This variable will hold the current state's instance. We need a function to handle the changing of states. Let's name it changeState, and it will be a public function and will receive an integer parameter state. Before we implement the function, let's first create both the state classes. Both the classes need to implement the interface iState. Back in the game class, let's now implement the change state function. We will use a switch statement to assign the current state. If state is 0, we will assign a new lobby instance. And if it's 1, then it will be a new instance of race. Now let's add it onto the stage. Because current_state is not a display object, we need to cast it as a sprite. Now, in the onComplete function, let's call change state and pass 0 to it. So what will happen now is that once all the assets are loaded, the state will be switched to lobby. Let's test our code. The asset loading was complete, and then the lobby was initiated. Next, we are going back to the Starling Builder editor and design the lobby UI layout. The root container is a layout group, so let's add an anchor layout to its layout property. Next, let's add its layout data. %width and %height to 100. Let's create a new layout group and name it Center Layout. Next, let's add the game's title image into it. Let's add layout data for center layout so that it always aligns to the center of the root container. To achieve that, just set both horizontal center and vertical center to 0. Next, let's add a button into the center layout. Let's name it Start Button. Let's add a background skin for our root container. And use tile grid for it. Now let's save this layout. Open our project folder, then Assets. I am going to create a new folder and name it Layouts. Inside it, let's save the layout as lobbyui.json. before we add this layout to our game, let's once test it. Everything looks good. So let's get back to VS Code and load this layout in the lobby class. First, let's check the lobby UI JSON file we just created. You can see that all the information we configured in the Starling Builder editor is neatly captured here. Next, we need to include this JSON file in our asset managers and queue array. Starling Builder has a UI Builder class that will create the layout. All we need to do is pass the UI object into it. So let's first create a public variable for the UI Builder. Let's instantiate it in the onComplete function. UI Builder's constructor requires an asset mediator instance. As the name suggests, the asset mediator class mediates between the UI Builder and the asset manager to fetch the required assets for creating the layout. Let's create a private variable for the asset mediator. Instantiate it in the onComplete function. First, pass the asset manager's instance into the asset mediator's constructor. Then, pass the asset mediator's instance into the UI Builder's constructor. Next, let's go to the lobby class and load the UI layout. So, what we need to do is first get the UI object from the asset manager and then pass it into the UI Builder's create function. Now, we need to access the game class's asset manager property here. But we don't have the game class's instance because it was created by Starling. Remember? At the beginning, we did pass the game class to the Starling constructor. Also, you might be wondering, why bother so much? After all, there are other ways to get the game class's instance in ActionScript 3. I know, but for this tutorial, let me show you a different approach, or rather, the correct way in the Starling world to access the root class's instance. Let's go to our main class and create a public static variable called root of type game. Let's create a getter function for it. Now, we need to attach an event listener to the Starling instance, and the event should be root created. So what happens is that once the root object is fully initialized and added to the display list, Starling dispatches the root created event, and also passes the instantiated game object along with it. In the onRootCreated function, we store this incoming game object in the static variable root, which serves as a global access point. This allows any class to access the main game instance without needing to pass it as a parameter. Also, make sure to remove event listeners when they're no longer needed. It's a good practice. Next, let's add the getter functions in the game class as well. Back in the lobby class, let's fetch the UI layout object from the asset manager using our main class's static variable root. And just pass the layout file's name, lobby_UI. So now we have the UI object ready, and all we need to do is ask the UI Builder to create a layout from it. But before we do that, let's create a sprite variable, because the UI Builder's create function returns a generic object, which can be typecast as a sprite, since it represents a display container. Let's name it main_sprite. Now, main_sprite is equal to turboshift.root uibuilder.create, and just pass the UI object into it. Just typecast it as sprite. That's it. Now just add main_sprite onto the stage. Let's test it. Layout group not defined? But did we not already add Feathers UI to our project? This is actually one of the most frequently asked questions among Starling Builder users. Let me explain. There is a technique in modern compilers called dead code elimination. To reduce the size of the executable, the compiler will only link the code that's directly used in the source files. In our project, we haven't used the layout group class yet, so it's not linked into the final build. When the UI Builder class tries to create a layout group dynamically from the layout, it can't find the class and throws an error. To fix this, we need to make the compiler aware that the class is being used. All we have to do is reference the class somewhere in the code using a dummy variable like this. You can see here that the layout group class is now imported. But when you remove the dummy variable, the import gets disabled and gets marked as dead code. Another way to overcome this issue is by using linkers. Create a public static array and add the classes that need to be linked to our project. Let's check our UI layout once to confirm which other classes needs to be linked. So there's layout group, which we've already linked, then there's anchor layout, and then there's the Starling button. I hope that's all we need to link. You can see here that all the classes have been successfully imported. All right, now let's test the build. The lobby UI layout loaded exactly as it was designed in the editor. We can even click the button. But wait, how do we listen to the button click event in code? Let's find out. First, we need to make a small change in the Starling Builder editor. Select the button and add an underscore in front of its name. Then, save the layout. Now, back in the lobby class, if you check the UI Builder's create function, you'll notice it accepts two additional parameters. The first one trims leading spaces. Since our layout doesn't have any, we'll set it to false. The second parameter is a binder object, and we're going to pass the current instance of this class. Why? Because internally, the engine will recursively look through all display objects in the layout, whose names start with an underscore. It then tries to assign those objects to public variables in the binder object, matching by name. So by passing this, we're telling the UI Builder to bind the Start button from the layout to this class's Start button variable. So all we need to do is declare a public variable using the exact same name. In our lobby class, this variable will be ready to use right after the UI Builder finishes creating the layout. You might feel a bit uneasy using an underscore prefix for public variables. After all, it's usually a convention for private ones. But in ActionScript 3, private or protected variables aren't accessible from outside the class, so this is a convenient trade-off. Now, let's add the event listener for the Start button. If you have worked with Flash programming before, you're probably used to mouse events for button clicks. But Starling handles this differently. When a button is clicked in Starling, it dispatches an triggered event instead. So when the Start button is triggered, we want to switch from the lobby state to the race state. Let's call the game class's change state function and pass 1. Now, what happens is that the switch statement changes the current state from lobby to race state. Then, what will happen to the existing lobby state? Good question. We need to handle it before switching states. That is, we must check if current state is not null. If it's not null, then destroy it. Which means we need to implement the destroy function for both the states. Let's first go to the lobby class. Let's remove this line. First, let's remove the main sprite and dispose it. Then, we have Start button's event listener. Let's remove that too. And finally, we need to remove the current instance of the lobby state, For that, we just need to call this dot remove from parent and pass true to it. Let's add a trace statement for the debug console. Lobby state destroyed. Now let's test the build. Click Start. And there it is. The console shows lobby state destroyed and race state initiated. Cool. Next, we need to start working on the race state. But before we move on, let's quickly implement the update function of the lobby state. Now, you must be already familiar with the enter frame event and how time passed is used to make things move with it. Also, earlier, when I showed you the final game, you would have already imagined the whole code around an enter frame event, right? But tell me this, in your imaginary code, did the lobby class have an enter frame event? No, right? I agree. The lobby state doesn't actually need one, because there is nothing in there to move with an enter frame event. But for this tutorial, I have something else in my mind. So we're going to add one and create a cool effect with it. So one thing is clear now, we need an enter frame event for both our states. And instead of using separate events in both, we can actually implement one event in the game class and use its current state to call the update function. So let's add an enter frame event listener right after a state is added onto the stage. And here we will call the current state's update function and pass the event's time passed value to it. What happens now is that for every frame, the current state's update function will be called. Also, we have to remove this enter frame event before switching of the states. Let's update both the state's update function and test the code. Everything worked as expected. Now, let's implement the update function of the lobby state. So, the plan is to add a nice smooth scrolling background effect to the lobby layout. To do this, first we need to change the root layout's name by adding an underscore in front of it. Let's also update its name to root_layout. Save the change. Now, let's create a new public variable and name it root layout. Next, create a private variable, tile image of type image, and another private variable, scroll rect of type rectangle. So, what we are going to do is, we need to get the tile image used for the background skin from the root layout. Background skin is a display object, so we need to cast it as an image. By now, you should have already learned that Starling's image class has a cool property called tilegrid. So our next step is to get the tile grid of that tile image and assign it to scroll rect. Let me show you the same in Starling Builder. This is the background skin of the root layout, which holds the image of a tile. And scroll rect would be that image's tile grid, which is a rectangle. Let's reset its values to 0, so we can use the original tile size, which is 64 by 64. Save the changes. Now, in the update function, we are going to increment the scroll rect's x value by 1, and then assign it as the tile image's tile grid. What's going to happen? Let's find out. It gives a nice smooth scrolling effect. It's too slow, isn't it? Let's increment it by 2 instead. Now it looks good. This time, let's update its Y value also. Or instead of incrementing, let's try decrementing for a change. Looks really good, right? Now, I am confused. Which configuration should I go with? Okay. I've decided to increment the Y value by 2. Let's test it one more time. This creates a nice illusion of motion, doesn't it? Like the title and the button smoothly drifting forward. Also, it's going to sync perfectly with the road scrolling animation we're going to do next. And maybe later, we can add a shifting effect to complement the name, Turbo Shift. Let's now move on to the race state. Let's start by creating a private variable called current speed, which will control the speed of the race. As the race progresses, its value will gradually increase, simulating acceleration over time and making the gameplay feel dynamic and challenging. To begin with, we'll set the initial value of current speed to 5. The first thing we're going to add to the race state is the road. We'll also make the road scroll based on the current speed, creating the illusion of motion and giving the player a true sense of racing forward. Let's create the road class. Please note that, in this tutorial, every sprite class that is going to load its UI from a layout will include a property called main_sprite. That's the convention I will be following throughout. Next, let's create the UI layout for the road class. Click on New to create a new layout file. By default, the root container is set to layout group. We're not going to use any layout properties here, so let's just leave it as it is. Now let's add the road image. If you check the asset list, you'll notice there's no texture available. That's because we haven't added it to the texture atlas yet. And the reason is, the image size is quite large, 640 by 960. There's technically no problem with including large textures in the texture atlas, but personally, I prefer not to. Instead, I include such images as backgrounds and let the asset manager handle them directly. So let's locate that texture file and copy it into our project. You can see the image size here. Let's go ahead and copy it. Now head over to your project folder. Open the Assets folder. And instead of placing it inside the Textures folder, let's add it to Backgrounds folder. Now let's switch back to Starling Builder. Keep in mind, it won't automatically detect the new asset. We need to reload it. Before that, let's save the layout first. And there you go, it's now visible in the Others section. Let's add it to the canvas. We'll reposition it to the top left corner. Since the canvas background color is white, we can't really see the image clearly. Let's change the canvas color to black to fix that. Now, let's rename this image to road_1. To create a scrolling effect, we'll need 2 road images. So, let's duplicate this one. Just click Duplicate. Then rename the second one to road_2. Finally, let's save the changes. Back in VS Code, we need to add the road UI layout in the Asset Managers and Queue array. We also have to include the road tile PNG we added to the backgrounds folder, remember? Now over to the road class. We'll start by getting the UI object from the Asset Manager and passing it to the UI Builder, just like we did earlier in the Lobby class. Next, we'll integrate the road class into the race state. First, let's create a private variable called road of type road. Then in the constructor, we'll create a new instance of it and add it to the stage. Let's test the code once to make sure everything is working correctly so far. Nice! Now, back in the road class, we'll create an update function that takes a parameter called speed. To animate the road, we need to access both the road images. So let's head back to Starling Builder and update their names with an underscore. You might already be familiar with the infinite scrolling technique commonly used in games. Ideally, the Y position of road underscore 2 should be at -960, but in the layout, it's placed at 0. This is just for design convenience. We will handle it directly in the code. Let's save the changes and head back to VS Code. In the road class, let's declare two public variables road underscore 1 and road underscore 2. Then, inside the constructor, we'll set the Y value of road underscore 2 to -960. Now, in the update function, we'll increase the Y value of both images using the speed parameter. And once either image moves past the bottom of the screen, we'll simply reset its Y position back to -960, creating a smooth loop. Back in the race state's update function, we will call the roads update method and pass in the result of current speed multiplied by the time passed parameter. Let's test it. Oops, a null object reference? Looks like we missed something. Let's check. Of course, we forgot to assign the binder class in the layout. Let's add it now. Testing again. Perfect. We now have a seamless, infinite scrolling road. Next, we need to make the current speed of the race state increase periodically. Let's start by creating a new function and call it update speed. Inside this function, we'll simply increment current speed by 1. Now, the challenge is, how do we call this function every second? No worries, Starling got us covered. Let me explain. In traditional Flash development, we often rely on enter frame loops or timer-based animations to handle anything that needs to happen over time. Whether it's waiting a few seconds, tweening an object, or playing a movie clip frame by frame. But in Starling, we have a much cleaner and more centralized way to handle all of that. It's called the juggler. The juggler acts like a smart timeline manager that runs every frame and keeps track of everything you want to update over time. One of the simplest and most useful features it offers is something called delayed call. Delayed call is similar to set timeout function in classic ActionScript 3, but it's fully integrated with Starling's timing system. That means it's more consistent, easier to manage, and it respects things like pausing the game or stopping the animation. Another feature is repeat call, which we'll now use to increase the current speed of the race at regular intervals. Repeat call works just like the set interval function. It allows us to call a function repeatedly at fixed intervals. It's an apt replacement for timer-based loops in Flash. Whether you're spawning objects, triggering animations at regular intervals, or running timed game logic, repeat call makes it simple and clean, all through the juggler. And soon, we'll use the same juggler to animate movie clips and tweets, making them play smoothly without manually tracking frames or using enter frame events. So instead of writing custom loops or juggling timers, we let Starling's juggler do the juggling for us, clean, centralized, and built for animation. And just so you know, there is always a default juggler available on the active Starling instance, which is all we need for the entire game. There's no need to create separate jugglers for each animation or delayed function call. You can access it via starling.juggler and use repeat call. Call the update speed function with an interval of 1 second. Let's add a trace statement to print the value of current speed to the debug console. Now let's test it. As you can see in the console, the value of current speed is increasing gradually. And at the same time, the road speed is also accelerating. Next, let's design the race UI. As usual, let's start off by setting the root container's layout to anchor layout. And then set the layout data to anchor layout data. One thing you must have realized by now is that the initial layout setup remains same for all layouts, so I won't repeat these steps in detail from here on. Next, add a new layout and name it main layout. Inside it, add a sprite and name it player car. This sprite is going to be our main protagonist. And obviously, we need to access it in code, so let's prefix it with an underscore. Now, add the player car texture. Next, set the player car sprite's registration point to the center. By default, the registration point for all objects will be set to the top left. Then, add the layout data for main layout. Top 0. Right 0. Bottom 60. And left 0. Let's reposition the player car sprite so that it stays at the bottom of the layout. We haven't saved this layout yet. Let's do it now. The reason why we set the bottom value to 60 and the rest to 0 is because we want the main layout to stretch horizontally and fill the entire width of its parent container, while vertically, Its top edge should align with the top of the parent, but its bottom edge should sit 60 pixels above the bottom of the parent container. If you want the layout to stretch and fill vertically as well, just set the bottom value to 0, or, like we did earlier with the root container, set both percent width and percent height to 100. The result will be the same. Now, let's add this layout to our race state. We need to add public variables for both main layout and player car sprite. Next, we need to add the main sprite variable. Adding Race UI Layout to Asset Manager. Let's copy this portion of the code and paste it here. Just change the UI layout's name to Race UI. Let's test it. Uh-oh. The output window is getting cut off. Let me resize it. Now the game screen is getting cut off. That's because we have not implemented the code to handle stage resizing yet. Let's do it straight away. We need to handle this in our main class. Add an event listener for Starling instance stage. It should listen for resize event. On stage resize, instead of using the Starling instance directly, I'm going to use starling.current.viewport, which is same as starling.viewport. This demonstrates that you can access Starling's active instance using starling.current, even outside the main class. By default, the viewport size will be same as the stage size. Now, when a stage resize happens, we need to pass a new rectangle to the viewport. And how the viewport is going to be resized can vary from game to game, or even from scene to scene. We can get the resized stage dimension from the event object and pass them to the viewport. But doing so means we will also require to write separate logic to resize the scene, which includes updating the size and position of every individual display object inside it. In this tutorial, we're going to resize the viewport in a way that keeps the aspect ratio consistent and always centers the game screen. In this way, we don't have to update the size and position of every individual display object. To achieve this, Starling provides a handy utility class called RectangleUtil. Its fit function lets you fit one rectangle into another. Here, we need to pass a rectangle with our default game size. And here, a rectangle with the resized stage width and height. We will be using the scale modes, Show All option, which scales the content, to fit entirely within the target rectangle while maintaining the aspect ratio. Now, let's test it. Let's try resizing. You can also see that the player car is 60 pixels above the bottom edge. Okay, next, in the race state, let's add the code to control the player car. Add an event listener to listen for the touch events. So, in the race state, when the player touches the screen, we want the player car to switch its lane. Again, we'll check for touch phase ended. And, oh, we don't have the lane positions yet. So, let's first create an array to store the lane positions. Next, let's calculate lane width using our main layout's width property. So, we have two lanes. The player car can be either in the center of the left lane, that would be lane width divided by 2, or in the center of the right lane, which would be lane width plus lane width divided by 2. Let's also have a property to store the player car's current lane position. Or, instead of storing the position, let's store the lane index. That is, if the player car is in the left lane, we store the value 0. Else, if it's in the right lane, we store 1. In that case, it's easy to check and switch. So, when the race starts for the first time, let's put the player car in the left lane. Now, in the on-screen touch function, we simply have to check if the player car lane property is equal to 0. If yes, then switch its value to 1. Else, switch it to 0. You must be already familiar with ActionScript's shorthand expressions. Now, just change the X position of player car sprite. Let's test. Awesome. We are unable to distinguish between the stage and the game screen. That's because we have set our stage color to black. Let's switch it to green and see how that looks. Oops. Looks like we also need to update our road UI layout. One thing we forgot to do in Starling Builder editor is to set the path for our layout folder. If you check the Files tab, you will see a message, Layout Path Not Found. Just go to Workspace in the top menu. Click on Workspace Settings. At the bottom, click the Edit button for Layout Path and select the folder where we've been saving our layouts. Now, simply reload the editor. And if you check the Files tab again, you should be able to see all the layouts in the list. We can easily switch between them. Alright, now select the Road UI layout. So, setting the canvas color to black here is just a change for the editor, and it won't affect the layout file. So, let's switch it back to white. Let's add a background skin for the root container. Save the layout, and let's test the build again. Back in the race state, we now need to add more cars on the road and build some traffic so that our player car can switch lanes and avoid collisions. Let's name the class for these other cars as enemy car. Why enemy? In game development, we often use terms like hero, enemy, spawning, etc. These are common game jargon. So, for this game, if we consider the player car as our hero, then the other cars on the road naturally become its enemies. So, let's go ahead and create that class. Now, you might be thinking, why can't we just add an enemy car sprite, just like we added the player car sprite in the race UI layout? Yes, that's correct. We could have done that. But I just wanted to show you that it's not always necessary to add everything in the UI layout. We can also create objects the conventional Starling way and use them alongside other objects that were created using Starling Builder's UI builder. Next, let's create a pool of enemies and spawn them on the road. So, let's create a private variable for the enemy car's image. Next, in the constructor, let's instantiate it and fetch its texture from the asset manager. We'll be using the asset manager's getTexture function. Now, we have more than one texture for enemy cars. Let's quickly check them in Starling Builder's asset list. So, we have a total of 5 different textures. For the time being, let's just use one, and that would be enemy car _01. And let's add it to the sprite. Alright, now that we are back in the race state, let's take a moment to figure out what we need to do with the enemy cars. First, we need to create a new enemy car. Next, we add it to the top of the stage. Then, in the update function, we will keep increasing its Y value so it moves down the screen. Once it goes off the bottom, meaning its Y value is greater than the height of the stage, we will simply remove or destroy it. So essentially, we are constantly creating and destroying enemy cars as the game runs. But here's the problem. Doing this repeatedly can lead to a lot of memory allocation and deallocation. That means the garbage collector is going to kick in often, which can cause stutters and hurt our frame rate. To avoid that, we are going to use a classic game dev technique called object pooling. Instead of creating and destroying enemy cars every time, we will create a fixed number of them at the beginning of the race. Then, whenever we need a car, we will pull one from the pool. And when it's off screen, instead of simply destroying it, we will simply return it back to the pool to reuse later. This is much more efficient, and it keeps the game running smoothly. Luckily, we don't have to write this class from scratch. Someone has already created it and shared it for us to use. So let's go ahead and download it and add it to our project. I've added the class to our source folder, so we don't need the original package declaration anymore. Let's go ahead and remove it. The class we are using is called Starling Pool. In the race state, let's create a private variable enemy pool of type Starling Pool. Let's instantiate it in the constructor. The Starling Pool constructor takes 2 parameters. The first one is a class reference. In our case, that should be enemy car. And the other should be the total number of enemy cars we want in the pool. Let's put 5. So, What's going to happen inside the Starling pool class is this. It's going to create 5 enemy car instances and store them in an array. Then, whenever we need one, we will use the getSprite function to fetch a car from the pool. And once that car goes off screen, we will call returnSprite to put it back into the pool, ready to be reused. Alright, first, let's create a private variable to hold the current enemy car instance. Next, we'll create a function to spawn an enemy. Inside that function, we'll fetch an enemy from the enemy pool and cast it as an enemy car. That's necessary because the getSprite function in the Starling pool class returns a display object. For now, let's just set its X value to place it in the left lane. Then, we'll add it to the main layout, so both the player car and the enemy cars are in the same container. Now, we want the spawnEnemy function to run at regular intervals, so let's use a repeat call function to handle that and give an interval of 5 seconds. To test if everything is working, let's add a trace statement inside the enemy car class constructor, just to see when it's being created. Let's run the code and check if it's all working as expected. Looks like we need to make a few changes. First, let's comment out the trace statement. Next, we need to center align the enemy car. To do that, we will simply call the align_pivot function on the current enemy instance. Alright, next up, let's add the code to move the enemy cars. To do that, we'll need an array to keep track of all active enemies that have been added to the main layout. Inside the spawnEnemy function, let's push the current enemy car into this active enemies array. Now, in the update function, we will loop through this array and increase the Y values of all active enemies. We will use a while loop here to iterate through the array. To move the cars, we'll multiply the race state's current speed with the time passed value. Let's also handle the cleanup for when an enemy car moves off screen. We will remove it from the active enemies array, then remove it from the main layout, and finally return it back to the enemy pool. Let's test the build. Oops, my bad. I forgot to decrement the I value. Let's fix that and test again. Now the cars are moving too slowly. Let's multiply the speed by 60 to get them moving at a more reasonable pace. Still there are issues. Let's take a closer look. Uh-oh. In the spawn function, before adding the current enemy car to the main layout, we forgot to set its Y value to the top of the screen. Let's fix that. Also, let's update our logic to spawn enemy cars in random lanes, instead of always placing them in the left one. Let's also lower the spawn enemy interval to 3 seconds. Now another thing. Currently, all the enemy cars are using the same texture. Let's improve that too. In the enemy car class, let's create a private function called getCarTexture. This function will randomly fetch one of the enemy car textures from the asset manager and return it. Let's update the texture name to enemy_car_0, followed by the generated random number. We've got 5 enemy car textures, so let's generate a random number between 1 and 5. Now, create a public function called reset, and inside it, just update the car image texture using the getCarTexture function. Then, we will call reset every time we spawn an enemy car, so each one gets a fresh, random texture. Also, let's increase the spawn rate. Change the spawn interval to just 1 second, so we see cars appearing more frequently. Let's test that. Next, we are going to implement collision detection. We will use a simple bounding box check for this. In Starling Framework, the bounds property is available on all display objects, including sprites. So, in the update function, within the while loop, let's check if the player car's bounds intersects with the enemy car's bounds. If the check returns true, that means a collision has occurred. Let's add a trace statement when that happens and test it right away. There you go, too many collisions. But that is not what we want. When a collision happens, we want the game to stop. To do that, we require a Boolean variable. Let's create one and call it game over. At the start of the race, we will set game over equals false. Then, inside the update function, we will wrap the whole movement logic so that it runs only if game over is false. The moment a collision is detected, we will set game over equals true, and that should stop everything from moving. Let's test and confirm that it is working as expected. Oops. Starling Pool just threw an error. But how did that happen? Oh, I see. It was because of the repeat calls. The spawn enemy function was getting called every second, and once the pool was exhausted, meaning no more enemy cars were available to fetch, the error was triggered. Currently, we have 2 repeat call functions running. We could either remove each one individually, or we can simply call starling.juggler.purge, which will stop and clear all scheduled animations and delayed calls from the juggler. That will safely abort everything managed by the juggler in one go. And crashed. You can see that in the first collision itself, everything stopped moving. Next, let's add some visual effects to show the impact of the collision. For this, we need to download some additional Starling filters. These are community-contributed filters and effects. That's why they're not included in the Starling Framework source code. Inside the SRC folder, you'll find 2 folders, Effects and Filters. What we need to do is copy the contents of the filters folder into the filters folder inside our project's Starling folder. There will already be some filter files there, so just make sure you're only adding the new ones without replacing anything important. After that, copy the entire effects folder into the Starling folder. That's it. Now we're ready to apply some visual effects for the crash. Open Starling Builder and select the Race UI layout. Select the player car sprite, and in the Properties section, you'll find the Filter property. Click on the Edit button next to it. This will open a window with a list. From the list of available filters, select the sine wave filter. Set the frequency to 30 and amplitude to 10, then click OK. Now the player car sprite will appear crumpled, which works well as a crash effect. Let's save the layout and get back to VS Code. Before we test the build, let's once look at the player car property. It's currently of type sprite. Since the requirement has come up for controlling its properties, let's create a separate class for it. Let's call it player car. Inside the player car class, let's create a private variable to store the sine wave filter. Next, in the race state, let's rename its class type from sprite to player car. Also, in Starling Builder editor, select the player car sprite and set its custom component class name to player car. Now, back in the player car class, we need to implement iCustomComponent interface. This is essential. Otherwise, the init component function won't be called by the UI builder. Inside the init component function, we will assign the existing sine wave filter to the property damaged filter. Then, we will set this .filter to null, because when the race starts, the car should appear normal. Next, let's create a public function called crashed, and inside it, apply damaged filter to this .filter. Now, in the race state, when a collision happens, just call the function playercar.crashed. Let's test it. Next, let's add the same filter in our enemy car class as well. The only difference will be in the crashed function, we will create a new sine wave filter instead of simply assigning it. Just call the function enemy.crashed. Let's test it. Looking good. Now, in the reset function, let's add this .filter is equal to null. All right, now let's bring in some particle effects. And I'm pretty sure I don't have to introduce you to the Stardust Particle Engine. Originally built for ActionScript 3, Stardust now fully supports the Starling framework, and the best part? It comes with its own editor. So let's just go ahead and download and install its editor first. You can see that there are lots of options for us to tweak and control. The best part is we can preview the changes instantly. They have also included a few ready-to-use effects as examples. Let's try them out, one by one. Wow! Check this out! This effect has a deflector. Cool! So, here's what we're going to do. Let's use the big explosion for the collision in our game. Sounds good? Click on Save As. Navigate to your project folder. Inside the Assets folder, create a new folder called Particles and save the effect file there. Now back to VS Code. First, let's check the particle file. Interesting. It's saved with a SD extension. Next, we need to add this particle file's path to the Asset Manager. Just rename its path accordingly. Finally, let's create a new class to represent this particle effect. Let's name it Big Explosion. Next, we need a sprite container where the particle effects are going to be rendered. Let's name it sim_container. Next, we need to add a variable for the loader, which will load the particle effect, and a variable for the player to play the particle effect. But before that, we need to download 2 files and add it to our project folder. Copy these 2 files. Then, open our project folder and create a new folder, libs. And paste them in it. Back in VS Code, open the asconfig file and inside compiler options, add library path, libs. Now, in the Big Explosion class, let's create all the required variables and instantiate them in the constructor. Please note that it should be a Flash event instead of a Starling event. To load the particle effect, first, we need to get the particle effect from the Asset Manager as byte array, and then pass it on to the loader's loadSim function. Once the simulation is loaded, let's remove the event listener. Then, create a project instance and assign it to the player. Next, we need to set the render target so that particles are rendered to SimContainer. Next, we need to create a public function which will start playing the particles effect. Let's name it Play. Inside this function, we need to add an EnterFrame event listener. Now, EnterFrame event should be a Starling event. So, we need to make a few changes in the code to support the use of both Flash and Starling events simultaneously inside the same class. Inside the onEnterFrame function, just pass event.pass times value to player's step simulation function. And when the number of particles becomes 0, just remove the EnterFrame event, otherwise the particles effect will simply play in a loop. Also, since we will be reusing this effect, let's reset the simulations in the play function. Back in the race state, let's first create an instance of Big Explosion. In the constructor, let's instantiate it. And in the update function, when the collision takes place, add the Big Explosion to the main layout. Let's set its position same as that of the player car. And then, call its play function. Let's test. The explosion must appear at the collision point, right? Let's fix it. To get the collision point, all we have to do is this. First, calculate the intersection area between the two colliding cars. This gives us a new rectangle. Let's call it as collision area. Then, to find the center of that rectangle, which will be our collision point, simply add half the width and half the height to the top left corner of the collision area. That's the exact point where we position our explosion effect, so it appears visually accurate. Awesome! Next, we're going to add a second particle effect. And this time, we want the player's car to catch fire after the collision. So, let's use this blazing fire effect. Save it in the same particles folder and get back to VS Code. Add the blazing fire particles path in the Asset Manager. Let's create a class for blazing fire. Let's copy-paste the code from the Big Explosion class. Oh, we have to import all these classes again. Instead, let's copy-paste the whole code from the big explosion class and rename it accordingly. Now, for Blazing Fire, we don't need a public play function. Instead, we will start playing the effect as soon as it's loaded. And since we want the fire to keep blazing without stopping, we don't have to check for any condition in the onEnterFrame function. Now, inside the player car class, all we have to do is to add an instance of Blazing Fire in its crashed function. Let's test it. Uh-oh. We've applied the sine wave filter on the player car sprite, which is causing the Blazing Fire effect to freeze. Let's fix it. So, open the Starling Builder editor and load the Race UI layout. So, what we are going to do here is, rather than applying the filter on the entire parent container, let's apply it specifically to the player car image, so it won't affect the Blazing Fire effect. Select the player car sprite and remove the applied filter. Just set it to null. Now, select the player car image and set its filter to sine wave filter. Save the layout. Back to VS Code. In the player car class, let's create a new private variable for player car image. And in the initComponent function, assign its value by using getChildByName function. Just a quick note, this is actually an alternative way to access UI components from UI layouts. With this approach, we don't need to prefix their names with underscores or bind them to public variables. Now, we just have to replace this with player_car. Everything worked as expected, but a couple of things we still need to tweak. First, we need to adjust the position of the Blazing Fire so that it aligns correctly with the player car. Second, we will add a short delay so the fire starts a few seconds after the collision, making the sequence feel more natural. First, let's set the Blazing Fire's X position at 50. Next, we will add a delayed call. Before that, let's quickly create a function, add Blazing Fire. Then, copy-paste this portion of the code in it. And now in the delayed call, let's call the function, add Blazing Fire, after 1 second. Now, there is an issue with our code. In the race state, when the collision happens, we are calling starling.juggler.purge. That function removes all objects currently added to the juggler, including our delayed call for add Blazing Fire. So the fire effect never actually starts. Let's test it once to confirm, but I'm pretty sure we are not going to see the Blazing Fire. See, told you. Now, one way to fix this issue would be to call starling.juggler.purge before we call the crash function on the player car. That's because the delayed call to add Blazing Fire function will be added after purging. Everything worked fine, but guess what? We got a new problem. Depth issue with enemy cars. No worries, easy to fix. In the race state, inside the spawn enemy function, where we add a new enemy car to the main layout, just use add child at instead of add child, and pass 0 as the index. This ensures that the depth of the enemy cars will always be lower than the player car. In other words, the player car will always appear on top of the enemy cars. There you go. Finally, everything is working fine. Next, let's improve the spawning enemy logic for this game. Right now, we are spawning a new enemy car every second using a repeat call. Let's change that so a new enemy car only spawns after the current one is removed from the main layout. Which means, when the enemy car disappears off the bottom of the screen, a new one will appear from the top. So first, let's comment out this line of code. Then, call spawn enemy function here, inside the update function. And don't forget, we also need to call spawn enemy in the constructor, because the first enemy car should spawn right away without waiting for any condition. Otherwise, there won't be any enemy car on screen for the update logic to remove. Let's test it. After the collision, the player car should not move, right? Let's fix that straight away. All we have to do is immediately remove the touch event listener after the collision. See, it's not moving anymore. Hang on, I just realized that I missed one step. I was supposed to show you another way to fix the juggler purging issue. Let's do that now. Instead of using the juggler's repeat call directly, we will create a private variable of type delayed call. Let's name it increase_speed. Now, we can comment out this line. And below, let's instantiate it with the same parameters used for its repeat call. And the only additional to do is setting its repeat count value to 0, which will make it repeat indefinitely. Now, in the update function, we can safely remove the purging line. And use starling.juggler.remove and pass the delayed call variable. This way, we are only removing this specific delayed call instead of purging everything. Oops, we forgot to add increase_speed onto the juggler. Let's add it here. And test it out. Cool. Next, let's add a bit of randomness to the enemy car spawning logic. This one's pretty straightforward. We will set the Y position of the enemy car by multiplying its height with a negative random number between 1 and 5. That way, each enemy will spawn a bit differently from the top. Alright, let's check how it looks. Next, we need to improve how our player car moves. Instead of just switching its X value between lanes, let's use Starling's tween class to animate the movement. The great thing about Tween is that it can animate any numeric property, whether it's a number, int, or uint. First, let's create a private variable of type Tween, and name it TurboShiftTween. Then, inside the on-screen touch function, we'll instantiate it. First, let's comment out this line. We'll pass the player car as the target object and set the duration for the tween. After that, we'll call its animate method to define which property we want to tween. In our case, that's the exposition, and set its target value to the new lane's exposition. Once that's done, we just need to add this tween to Starling's juggler. So now with every touch on the screen, a new tween gets created and added to the juggler, smoothly shifting the player car. Let's test it. Looks really good, right? Oops, that doesn't look good. The player car should have stopped right at the collision point. Okay, we've got a small issue. The turbo shift tween should stop immediately when a collision happens, and the player car should freeze right at the collision point. So, to fix that, we'll simply remove turbo shift tween from the juggler inside the collision handler. Let's give it a shot. Yes, that fixed it. Now, what if we want to tween multiple properties at the same time? Like, when the player car changes lanes, it should also slightly rotate in that direction. Guess what? It's totally possible, and we don't even need to create a separate tween for it. First, let's create a local variable to hold the rotation value. And based on player car's current lane index, it will be either positive or negative 0.2 radians. Please note that, unlike Flash, which sometimes mixes degrees and radians, the Starling framework expects all angles in radians consistently. Now, all we have to do is add one more animate call on the turbo shift tween, this time for the rotation property, and just pass in the rotation value. Let's test it. Interesting. So that means once the tweening is complete, the player car should rotate back to 0. Luckily, Starling's tween class supports callbacks that can be triggered when the tween starts, on every frame update, or once it finishes. To call a function when the tween completes, we simply use onComplete. Here we can either pass a function name or just use an inline function like this. Inside it, we'll simply reset the player car's rotation value back to 0. Or we could create a new tween and animate it smoothly back to 0 instead. Now, if we're animating just one property, that too, for a very short duration, and we don't need any control over the tween, then we can directly use Starling's juggler class to tween. Like this, starling.juggler.tween, and just pass the object, then the duration, and finally the properties to animate. Rotation, 0. That collision is not perfect. Keep in mind, all those bounding boxes are upright rectangles. A rectangle object doesn't have a rotation property. So when the player car image is rotated, its bounding rectangle will simply grow in size to fit the rotated image. This means the collision detection might not be precise in every scenario, but it's good enough for many purposes. And if this method isn't accurate enough, you can always switch to a more precise collision detection technique, which won't be covered in this tutorial, but I definitely encourage you to explore on your own. Let's move on to scoring now. In the Race UI layout, Let's add a new layout group and name it Top Right Layout. Set its layout data with top equals 10 and right equals 10. This will align it to the top right corner of the screen. Next, add two text field components into it. One will display the score label, and the other will show the score value. Now, format the text on both fields as needed. And make sure to enable the batchable property for all text fields. Otherwise, Starling will render text fields separately, leading to extra draw calls. Save the layout. Back in VS Code. First, let's add the required public text field variables. We'll also need a variable to track the current score, so add that and initialize it to 0 inside the constructor. Now, in the update function, right where we check if the enemy car has gone below the screen, let's increment the current score value by 10 points, and then set the score text field's text to reflect the updated score. Or, let's do one thing. Let's create a separate function for this and name it UpdateScore. And then, here just call UpdateScore 10. We also need to call UpdateScore 0 once in the constructor to initialize the score display. All right, let's test it. You can see here in the top corner, the score is updating each time an enemy car leaves the screen. Okay, cool. Next, we're going to work on the Game Over pop-up. Open Starling Builder and create a new layout. This is going to be a full-screen pop-up, so let's go ahead and apply the usual settings. Now, let's create a main layout and align it to the center of the root. Save the layout. Wait, actually, instead of adding an image component, let's use it as a background skin. First, We need to set the width and height of the main layout to 400. And then, assign the image as its background skin. Let's apply a scale, 9 grid, to ensure proper scaling. From here on, I'm not doing anything new that you won't understand, so you can just watch and learn. Let me quickly explain the functionality of the game over pop-up. After a collision, we're going to display this pop-up. It will show the final score and give the player two options to choose from. When the player clicks the Play Again button, the race should restart from the beginning. When the player clicks the Quit button, the player should be taken back to the lobby. That's it, save the layout, and let's get back to VS Code. First, let's add the layout path to the Asset Manager. Next, create a new class for the Game Over pop-up. Add all the required properties, and don't forget to refer the UI layout, and include all the public variables necessary for data binding. Otherwise, it will throw errors. Now, let's add event listeners for both the buttons. To implement the restart functionality, we will need to make a major change in the race state. Let's begin by creating a separate function and name it Reset Race. Please note that this should be a public function because we should be able to call it from the Game Over pop-up. In this function, we are going to reset everything related to the race. So let's start with the enemy cars. For each enemy in Active Enemies array, we are going to reset their Y value to the top of the screen. Then we need to call their reset function. And finally, we have to return them back to the enemy pool. Now we can safely empty the Active Enemies array. Next, we have to reset the player car. But for that, we need to add a reset function in the player car class. In the reset function, we need to remove the filter applied on the player car image. Then we need to remove the blazing fire. For that, let's create a separate function. And now, call it here. Back in the race state, let's call the player car's reset function. And in the Game Over pop-up class, inside the function onPlayAgain, let's call the race state's reset race function. Now in the race state, we need to display the Game Over pop-up. Let's create a private variable for it and initiate it here in the update function. To display the Game Over pop-up, let's use Feathers UI's Pop-up Manager class. Pop-up Manager allows us to display content on top of our application. And in the Reset Race function, we have to remove this pop-up. Now, in the Game Over pop-up, we need to display player score. For that, we need to make a small change in Starling Builder. Select this text field and rename it to Player Score Text. Save the layout and get back to VS Code. Let's add the public variable, Player Score Text. And in the race state, let's pass current score value into the Game Over pop-ups constructor. Let's fix that issue with the Game Over pop-up class. And then, display the score value in player score text. It's time to test our Game Over pop-up. You can see that the score is displayed correctly in the pop-up. Now, let's test the Play Again button. Oops, after resetting the race, we forgot to restart it. No worries, let's fix that next. So let's go ahead and create a new function called Start Race. All the code we need for this function is already sitting inside our constructor. Let's just copy-paste that setup code from the constructor into Start Race. Now, inside the Reset Race function, we'll call Start Race to begin the race again after a reset. And don't forget, we also need to call Start Race from the constructor so that the race starts when the state is first created. All right, all set. Let's test it now. Click on Play Again, and there you go, the race starts again. We're not going above 60, huh? Let's play one more time. Oops. Next, we'll implement the Quit button. But before that, one more round. Oh, look at this. After the crash, the player car hasn't fully recovered. Maybe we need to take it to an actual garage. Just kidding. Let's fix it. All we have to do is, in the reset function of the player car class, set its rotation value to 0. Now let's implement the onQuit function inside the Game Over pop-up class. But before that, in the race state, let's create a new function. Name it Quit Race. Inside Quit Race, copy-paste the pop-up removal code. Then call the Change State function to go back to the lobby state. All right, let's test it. Something's off. The Game Over pop-up is appearing too quickly and blocking the collision effect and the blazing fire. Let's fix that first. Let's add a short delay before displaying the Game Over pop-up. I know, we were supposed to test the Quit button, right? But we'll do that later, after fixing this. Let's cut this from here and add it to a new function called Display Game Over Pop-up. Let's also create a function for removing the pop-up and call it Remove Game Over Pop-up. Now let's cut this portion of code from here and add it to this new function. Then, just replace these two lines with a call to remove Game Over Pop-up. Similarly, we need to call Display Game Over Pop-up here, but with a delay. So let's use the delayed call functionality of the Juggler class. And let's give it a 3-second delay. Hope that should be okay. Well, let's find out. The 3-second delay is fine, but the pop-up is still covering the blazing fire. We need to position it a little higher. Open Starling Builder and select the main layout. In the layout data, we have currently positioned it at the center of the root layout. Let's replace the vertical center to nan. And add a 100 to top, so it will be 100 pixel away from the top. Yeah, that should be fine for us. Click OK and save the layout. Let's run the project. Oh yeah, this looks fine, right? Now let's test the quit button. Oops, what could be wrong? Oh, we need to call quit race function here. What? Is it an error? Yeah, we haven't implemented the destroy function for the race state. That's why it's throwing this error. So let's do that. Let's also implement destroy functions in all the required classes. Did we miss something? We missed quit race. And with that, everything is working smoothly, the game loop is complete, and all systems are go. All right, let's take a break from the race state for now and switch back to the lobby state. Next up, we are going to set up a way to store the player's best score and add functionality to fetch and display it on the lobby screen. We will start by designing the UI. So open Starling Builder and load the lobby UI layout. Then select the main layout and add a new text field to it. Let's name it as Best Score Text. Let's format the text field accordingly. Let's arrange it properly within the main layout. Now let's save the changes and get back to VS Code. Straight away, let's declare the public variable, best score text. Now, the thing about best score is that it should be persistent. That is, it must outlive an application restart, which typically means we have to write the respective score value into a file on the disk. For that, we are going to use ActionScript's shared object. Since we will require to access this best score from both the lobby and the race state, let's declare it inside the game class. So here's what we need to do. First, declare an integer variable to hold the best score value. And then, declare a shared object variable to store and retrieve this value. Let's name it as best score. And let's add getter and setter for it. Now, let's create the shared object variable and instantiate it in the constructor by using the getLocal function of the shared object class. A local shared object is identified by a simple string. In our case, it's TurboShift data. Now, in the getter function of best score, let's replace this line with the following code. What it does is, It checks if the best score value stored in the shared object is null or not. If it's null, then return 0. Otherwise, return the value as an integer. And in the setter function, let's store the best score value in the shared object variable by using its setProperty function. We can also call its flush function to immediately write it to a local file. Just think of shared object as a persistent dictionary object. Now in the race state, when the collision happens, let's check. If the current score value is greater than the best score value. If yes, then replace the best score value with the current score value, which will be saved in the shared object immediately. Let's add a trace statement here. And now in the lobby state, all we have to do is assign the best score's value to the best score text field's text as a string. Let's test it. Oops, it should have been best score 70. Let's fix it by adding the string best score before the value. Let's test again. Look, it's displaying correctly here. Let's see if it's updating the score properly or not. Cool. Everything is working as expected. Next, we're going to create a simple leaderboard and display the player's best score in it. Just a heads up, we won't be covering any backend services or database setup in this tutorial. Instead, we'll be using dummy data to simulate the leaderboard. All right, so let's get started. In Starling Builder, we already have the lobby layout open. Now, let's create a new layout to place the leaderboard icon. First, select the root layout and add a new layout inside it. Rename this one to bottom right layout. And set the layout data as bottom 5 and right 5. Next, let's add the leaderboard icon from the Asset tab inside the bottom right layout. Just make sure it's set to type button, not image. Rename it by prefixing an underscore and change its name to leaderboard button. Now go ahead and save the layout, and let's switch back to VS Code. Back in the lobby state, let's declare a public variable to bind the leaderboard button. Then, inside the constructor, add an event listener for it. This is where we'll handle the click and display the leaderboard. Let's do a quick test and see if the leaderboard button shows up on the lobby screen. Perfect. Just as expected. Now let's move on and create the leaderboard pop-up. Let's open Starling Builder and create a new layout. Now, most of the steps are going to be just like what we did in the earlier layouts, so I won't be repeating them. You should be able to follow along just fine. let's go ahead and save the layout. So everything we have done so far is quite similar to how we designed the game over pop-up. But from here on, things are going to be a bit different. Now, it's a leaderboard, right? Which means it should display a scrollable list of items that show player details, like their rank, name, and score. Yeah, we haven't designed the item itself yet, but let's set that aside for now and just focus on the list. Thanks to Feathers UI, we don't have to build the scrollable list from scratch. There's already a built-in component called List that does exactly what we need. Head over to the Feathers tab and select feathers.controls.list. Now let's give it an explicit size. For 50 by 500 should be fine. Let's position it to the center and save the layout. Now, we're getting this error because the list component is using a background skin, which is not from our texture atlas. As mentioned earlier, the Starling Builder editor is built entirely with Feathers UI, and by default, it uses a theme called Metalworks Mobile. So, most Feathers UI components come pre-skinned with that theme. That's why you might have noticed the list component already has a background skin that matches the editor. Now, to fix this issue, all we need to do is remove that default background skin and apply a new texture from the Texture Atlas. But what if you want to use a theme in your app as well? Well, in that case, you'll need to modify the default template used by Starling Builder and remove any conflicting properties. For the list component, you just need to remove the background skin property, since it's not needed when you're using a skin from the theme. You can also embed your own custom theme inside Starling Builder and design UI layouts with it. Unfortunately, I won't be able to walk you through that in this tutorial. If you're interested, you can always learn more about it on the Starling Builder website. So, let's apply a background skin to the list. Save the layout and let's get back to VS Code. Let's create a new class for our leaderboard pop-up. Let's copy a few code chunks from the Game Over pop-up class. That should help us set up the basic structure for the leaderboard pop-up. And don't forget to add the new layout in the Asset Manager. Now, back in the lobby state, let's declare an instance for the leaderboard pop-up. And instantiate it right here. We will be using the pop-up manager to show it on the stage, just like we did with the game over pop-up. Now, the game over pop-up didn't have a close button, but this one does. So, let's add a variable for the close button in the leaderboard pop-up class. Then, add an event listener for it, so when the player taps the close button, the pop-up will be removed from the screen. Before we test it, there's one thing to keep in mind. We also need to bind the list component to this class, otherwise it's going to throw an error. So, let's add a public variable for that as well. All right, let's test the pop-up first. Looks good, but we need to add an overlay to make it stand out from the background. Open Starling Builder, and for the root layout, let's add a background skin using a quad. Set the color to black. And it's alpha to 0.6. Save the layout. Hang on, did we add this overlay to the Game Over pop-up earlier? Let's check it once. Nope, there isn't one. We need to add one there too. This one's a bit too dark. Let's lower the alpha. Let's start by adding the overlay to the Game Over pop-up. .3 should be fine. Let's make the same change here as well. Save the layout. Yep, now it looks good. And this one looks good too. Next, let's work on the list component for the leaderboard pop-up. Wait, we haven't designed the item yet. Let's do that first. Back in Starling Builder, create a new layout. Let's set the root layout size to 400 by 80. Now let's add 3 text fields. The first one will display the leaderboard rank, the second one the player name, and the third one the score. So let's name each one accordingly. Now let's format each text field and give them different colors. Now let's arrange these text fields neatly inside the layout. Please note that this step we're doing just for aligning and spacing. Now we can safely remove the layout, not required anymore. Now let's add a background skin to the root layout. Now that we've added the background skin, we need to slightly shift the alignment within the layout. Let's do that. And save the layout. Next, let's load the leaderboard layout and take a quick look. Now, you probably want to see how the item we just designed fits into the pop-up, right? So to do that, we need to load the leaderboard item layout inside the leaderboard layout. To load a layout, just click the external button up here and select the leaderboard item's JSON file. Let's duplicate the item a few times to see how the list will look when filled. Now, when designing layouts, we might sometimes need to use placeholders or dummy items just to get a sense of the UI and how it looks. But we don't want them included in the final UI because we know we'll be handling those parts differently. In such cases, we simply need to tell the Starling Builder engine to ignore those items when building the final UI. To do that, first, select the item. Then, click on the Custom tab here and enable the For Editor checkbox. Now, repeat the same steps for each of these items. That's it. These elements will remain in the layout file, but won't be included when the leaderboard pop-up is finally created. Now save the layout, and let's get back to VS Code. Let's first add the leaderboard item layout in the Asset Manager. Next, let's create a new class for it. We named the class as Leaderboard Item Renderer because it's going to extend an item renderer class from the Feathers UI library called Layout Group List Item Renderer. Now, if you want to learn more about item renderers, I highly recommend checking out Feathers UI's documentation page. Unfortunately, I won't be covering it in this tutorial, but their docs are well written and explain everything clearly. Back in VS Code. Let's now declare the public variables for binding with the 3 text fields. Now let's rename them properly. For this class, we won't be using the constructor function, so let's remove it. And instead, Let's override a protected function called initialize. Let's declare a variable for the main sprite. Inside the initialize function, let's first call its superclass's initialize function. Next, let's copy the code from here and paste it here. Rename it to leaderboard_item. Now, here in the create function, there's a Boolean parameter called trim leading space. This tells the engine to trim off any unused space within the layout. That is, the area the root layout is not covering. For all our previous layouts, we left it as false, since their root layouts matched the canvas size exactly. But in this case, the root layout of the leaderboard item is not using the full canvas size. So, we need to set trim leading space to true, so that only the actual content area is used, and not the empty surrounding space. Next, we need to override another function, called commitData. Inside it, we are going to check if the data property is not null, then set the text field's text using the data, like. Now you might be wondering, how is it going to get its data, right? Don't worry, that's exactly what we're going to cover next. Let's go to the leaderboard pop-up class, and in the constructor function, let's assign a factory function to the list component. For that, let's use lists, item renderer factory property, to which we are going to assign a function which will return an item renderer. That is, we're essentially telling the list, instead of creating generic item renderers, use our custom factory, which will give you an instance of leaderboard item renderer for each item. Next, we need some data to display in our list. As I mentioned earlier, we will be using dummy data to simulate a leaderboard. So let's go ahead and declare a private array called leaderboard for storing dummy data. Please note that each entry in the leaderboard array is an object containing a player's name and their best score. For the rest of the entries, I'm just gonna copy-paste so that we can save some time. Next, in the constructor function, we need to set the data provider property of our list component. Since the leaderboard data is based on an array, we're going to set it as a new instance of array collection. Now, we need to add the leaderboard data onto our list's data provider. Let me again copy-paste that portion of the code just to save time. So, we are using a for loop to iterate the leaderboard array. First, we are assigning each entry to a local variable, player, of type object. Then, we're adding each player to the list's data provider using the addItem method. But please note that we're not just adding the raw player object, we're actually creating a new object with 3 properties: rank, name, and score. The rank is calculated as i+1 because array indices start at 0. But we want our leaderboard to show ranks starting from 1. We're also pulling the name and score from the original player data. So that's it. Our leaderboard pop-up should be ready by now. Let's test and find out how it looks. Oops. Seems like we gave the wrong layout name. Oh, it should have been leaderboard_item_UI. Let's test again. What? We have not set any layout to horizontal layout. Then why this error? I think we forgot to remove the layout from the root layout after aligning its children. Just set it to null and save the layout. and test again. Okay, this time everything worked, but alignments are totally messed up. First, we need to align the list itself, and then we might have to add back the horizontal layout we just removed from the leaderboard item. Let's first fix the list's layout. It already has a layout, which is vertical layout. Let's just check how it's aligned. Yeah, let's change its horizontal alignment from justify to center. Let's also set a gap of 5 and a padding of 15. Save the layout. Next, like I said earlier, let's go ahead and add the horizontal layout back to the leaderboard item. Save the layout. Also, just to be safe, let's add both the layouts here in the linkers array. Oh yeah, I forgot to mention, we can now safely remove these two, as we've already declared few variables of their types. Oh, and not sure if you've noticed, but it's been a while that Starling's been reminding us to add depth and stencil to the application descriptor. Seems like our list component actually needs full mask support. So yeah, let's add that in the application descriptor and make sure it's enabled. Just add true to enable it. And let's test it. The alignment issues are now fixed, and the pop-up looks really good. But there are a couple of problems. The leaderboard isn't sorted by score, and we forgot to add our best score in it. Right now, it's all dummy data, so let's go back and sort these out. Inside the leaderboard pop-up class. First, let's push our best score into the leaderboard array. For name, let's use you. And we can fetch the best score from the root class. Next, we need to sort the leaderboard. Again, I am going to copy-paste that portion of the code. Now, you must be already familiar with the array's sort function. It simply compares two objects at a time, A and B. If A has a higher score, it returns -1 to put A first. If A has a lower score, it returns 1 to put B first. Equal scores return 0, which means no change in their position. Since it returns -1 for higher scores, this sorts our leaderboard from highest to lowest, perfect for our leaderboard ranking. Now let's test and see the changes. So the leaderboard is now sorted, and we can also see our score in it. But the UI UX designer in me somehow wants our score to stand out from the rest of the players. Hold that thought for a moment. Also, I can see a higher draw count here, which is not good. But let's leave that for now and take care of it later. So let's go ahead and make that UI UX change for our score. So what we are going to do is, here in the commit data function, we will simply check. If the player name is you, then change the font color of both the names and scores text fields. Let's change the name text field's font color to red and the score text field's font color to lime. That's it. Let's now test and see it in action. There you go. Now our score stands out from the rest. Now let's play one round and see if our best score is getting updated properly in the leaderboard. Uh-oh, just missed it by 10 points. You know what? Let's not waste time. Instead, let's cheat. So, instead of 10 points, now we will get 100 points per enemy car. Let's test. So, our current best score is 150, and we are at rank 7. So, our best score is now 300. And our rank in the leaderboard got upgraded to 6. So yes, everything is working as expected. So that's it. We have completed the leaderboard implementation for this game. Next, we are going to work on the settings drop-down in the lobby state. In Starling Builder, load the lobby UI layout. So first, let's add the settings button in the top right corner. For that, let's use a layout group. And name it Top Right Layout. Inside it, let's add the settings icon. Align the layout to top right. Rename it to Settings button. And let's straight away add it to the lobby state. Here, we need to display the settings dropdown. Back to Starling Builder. Inside the top right layout, let's add a sprite. And inside it, let's add a layout group. This layout group will contain all the buttons of the settings dropdown. Inside the buttons layout, let's add a sprite. And name it BGM Sprite. Inside it, we need to add 2 images. So let's first change this option to image. And add BGM icon and band icon. Now let's duplicate this sprite. And rename it to SFX Sprite. Now, let's change the texture of the BGM icon of SFX Sprite to SFX Icon. We need to add one more button to Buttons layout, which will be an actual button. So let's change this back to Button, and select the info icon. Now, let's arrange the Buttons layout. Next, we need to add the slider image into the sprite. First, let's change this back to image, and select the slider. Let's apply the Scale 9 grid to it. Now let's resize it accordingly. We also need to resize the button layout. Let's change the vertical alignment to bottom. So, all the 3 buttons are now ready. Let's rename the sprite to Settings Dropdown. So, when the lobby is loaded, the Settings dropdown will be off screen. And when the player clicks the Settings button, it will slide down to this position. That is, the Settings dropdown's Y position will be at 70. So, which means, initially its Y position should be at -270 to make it off screen. Let's note that and keep it on screen at 70. Let's save the layout and get back to VS Code. First, let's declare the public variable for the Settings dropdown. And in the constructor function, let's set its Y position to -270. Next, inside the onSettingsTriggered function, we'll tween the Settings dropdown so it smoothly slides down. But before we can test that, we need to declare all the public variables needed for binding. There is BGM Sprite, then SFX Sprite, and, oh, let's rename it to Info Button. And declare its public variable in the lobby state. Before declaring variables for BGM Sprite and SFX Sprite, first, we need to create a separate class for them. Let's name it Button Sprite. It will extend a sprite class. In the constructor function, we are going to set this.touchGroup to true. That's because we want this class to behave as a single touchable object. So any touch event will target the container itself and not the children inside it. So our button sprite has two children, BGM icon and ban icon. And we need access to its ban icon image. So first, let's create a private variable to store its reference. And then in constructor, we can use getChildByName to access the child object named banIcon. We know it's an image, so let's cast it as one. Next, we need to declare a public Boolean property called disabled. Let's generate its getter and setter functions. Now, we want the ban icon to be visible based on the disabled properties value. So let's set banIcon.visible equals disabled. Or, instead of setting its value in the constructor, we can set it in the disabled properties setter function like this. And remove this from here. Oops, I totally forgot. This class is supposed to be a custom component class, right? So we should have implemented it with the iCustom component interface. Sorry, my mistake. Let's fix it. And instead of the constructor function, we must use the initComponent function. Now, in the Starling Builder, for both BGM Sprite and SFX Sprite, let's set their custom component class as Button Sprite. Save the layout, and back to VS Code. Now, in the lobby state, let's declare two public variables of type Button Sprite, and name them as BGM Sprite and SFX Sprite. Everything looks good. So let's test it. The dropdown worked, but it doesn't look good, right? How about if we add a masking effect to it? Yeah, let's try that and see how it looks. Back to Starling Builder. Now, select Top Right Layout and add a new sprite into it. Select the sprite and, in the Properties window, click on the Edit button next to the Mask property. For masking, let's simply use a quad. Now, we need to give it a size, which should match the Settings dropdown. So let's give it a width of 70 and a height of 300, which is a little longer than the Settings dropdown's height. Now, just drag and drop the Settings dropdown into the mask sprite. And we can already see the masking effect here. Oh, the mask is placed a little higher. We should bring it down a little bit. It should be placed somewhere here, at the center of the Settings button. Let's keep this here, just for reference. Now, select the sprite and let's edit the mask one more time. Let's change its Y value and see how it looks. 30 looks perfect. It cuts right at the center of the Settings button. Now, just change the Y value of the Settings dropdown and we can see it disappearing behind the Settings button. Save the layout and let's test the build. Now it looks good. So let's go ahead and implement the full functionality. Let's reduce the Y value here to 50. Let's also resize the Settings button's width to match the width of the drop-down. Here, I'm going to add an onComplete function, which will set up an event listener for touch events on the stage. Now let's add the event listener. And generate an event listener for on-touch stage event. Next, let's copy this portion of the code and paste it here. We need to import the missing classes. Inside this if condition, we're going to check the names of the display objects being touched by the user. To test that, let's first use a trace statement and see how the object names are being displayed. Let's test. Oops, we got an error. Oh, instead of importing the class, we generated a local variable. My bad. So let's remove this line and import the correct class instead. Now, as we touch each display object on the lobby screen, its name is printed in the debug console. The reason we're getting BGM Sprite and SVEC Sprite as the names of the display objects is because, in the Button Sprite class, we've set the touch group property to true. If this property were disabled, we'd be getting the name of the ban image instead for both. Let's test that and see the result. See, it's showing as ban image. That's because in the Button Sprite class, the ban image sits at the top of the display hierarchy and is receiving the touch event. And that would make it difficult for us to identify which button sprite was actually touched by the user. So let's go back and enable the touch group variable. So let's add an if condition to check the target object's name. If it's BGM Sprite, we will toggle its disabled property. Next, we will check for SFX sprite and do the same toggling for its disabled property. Please note that we only need to handle these two names, and for any other target, we will simply remove the settings drop-down from the screen. To do that, let's first create a new function called Remove Settings Dropdown. Inside it, let's use a tween function to remove it from the screen. Remember, earlier we used a tween function to display it. Let's copy this code and change its Y value to -250 so that the settings dropdown moves back up. We don't need the onComplete part, so let's remove it. We should also remove the touch event listener as it's no longer required. Let's copy this and change it to Remove Event Listener. Let's change the tween duration to 0.1 second. And let's call this function here in the else condition. So now when we touch BGM sprite or SFX sprite, it should toggle its state. And if we touch anything else, then the drop-down should be removed. Let's test that and see how it works. See, both the BGM sprite and SFX sprite are toggling as expected, and when we touch the info button, it's gone. Oh, something is wrong. Seems like there's an issue with the tween. Let's fix it. Yeah, when we click the settings button, the drop-down should only tween if it's not already visible. For that, first, we need to come down here and add an onComplete function to this tween. And inside it, set the visible property of the settings drop-down to false. Let's copy this line, and in the onSettingsTriggered function, let's add a condition to check if the settings drop-down's visibility is false. And it should only tween if its visibility is false, which means we actually don't require this function. Instead, let's convert it into an inline function. Or, even better, we can actually call addEventListener directly. We don't need the inline function. So, on complete, we will call addEventListener and pass these as arguments. Now, let's set the settings drop-down's visible property to false in the constructor. And we should set it to true before tweening. That's it. Now let's test. There you go. Looking cool, right? Next, we are going to add audio files to our project. I am going to copy all these files and add it to the Assets folder. First, let's create a new folder here. Let's name it as Sounds. Open it and paste it here. Back in VS Code, we now need to add all those sound files into our Asset Manager one by one. Just make sure their paths and names are accurate. Now, to play a sound, all we need to do is copy the file name, for example, Big Explosion. Then, so, this is where the collision takes place and the Big Explosion effect plays. So, let's go to the Big Explosion class. And in its play function, we'll call the playSound method of the Asset Manager class and pass the file name as a string. Here in the Debug console, we can check if all the sounds were added to the Asset Manager. Let's test it one more time. I forgot to mention, for this project, we'll be using a different library to manage all the audio files. Here, I'm just giving a demo of how we can easily manage sounds using the Asset Manager class. Next, let's see how we can play a sound in a loop. Let's take Game Loop as the example. Let's start playing the sound as soon as the lobby loads. To play a sound in a loop, all we need to do is specify the loop count. Here, I'm using a number like 999. Let's test that and see how it sounds. We now have two sound instances playing the same loop. That's a bug. Let's change this back to 10. Next, let's add the Sound.as library to our project for better management of audio files. Sound.as is a popular ActionScript 3 audio library that extends Flash's native sound capabilities. It provides advanced features like seamless looping, volume fading, sound grouping, and better playback control. Let's download it and unzip it to a folder. Inside the source folder, there is a folder named Tree for Truss. Copy it and open our project folder. Then open the code folder and paste inside it. We need to add one more file from the Sound.as folder. That's because Sound.as uses an external library called AS3Signals for event handling. Open the libs folder and copy this file. Then, in our project folder, this time, open the libs folder and paste inside it. That's it. Let's get back to VS Code. In the game class, let's first declare two variables of type Sound Manager. BGM Player will manage the game loop audio, and SFX Player will manage all the sound effects. Let's generate a getter for both the sound managers. Now, let's initialize both the variables in the constructor. Next, we need to load the audio files in the sound manager respectively. Before that, we can remove all these audio files from the asset manager. Let's load the sound game loop in BGM Player using the load sound method. Just mention the file path. We also have to specify a name for the loaded file. I'm going to keep it the same as the file name. Next, let's load a sound effect. For that, let's use the SFX Player to load the sound. Button click. Now, to play the BGM sound, let's go to the change state function. And here, use the play loop method of the BGM Player. Then, specify the sound name. I have set its volume to 0 because I want the BGM to fade in when the lobby loads. For that, first we have to get the sound from BGM Player. Just use getSound method. Then use the fade from method. We want the sound to go from 0 to 1 in just 3 seconds, or 3,000 milliseconds, and 1 being the maximum volume. Similarly, we can use the SFX player to play the button click sound effect. For sound effects, we should use the playFX method of the SFX player. Let's use the same code for all the buttons in the lobby class. Now, let's test it. In game development, we generally have 2 types of sounds. One is the global sounds, which play continuously throughout the game, such as looping background music or sound effects like button clicks. And the other one is state-specific sounds, which are unique to certain states or levels. The 2 sound managers we just created belong to the game class, which can be accessed from both the lobby state and the race state. However, our race state requires state-specific sounds, which are used only within the race state. Which means we need a separate sound manager for the race state, which will load all the state-specific sounds when the state loads and unload them when no longer necessary. This approach helps us with memory management. That is, by not loading all sounds globally, we can save memory and improve the performance of our game. So, in the race state, let's declare a private variable, audio player of type sound manager, and instantiate it in the constructor. Next, let's load all the sounds required for the race state. Now, when the race starts, the car loop sound should start playing immediately. We will again apply the fade-in effect here. And when the collision takes place, it should fade out and pause the sound. To pause the sound on fade out, we have to add a listener for on-sound completed event, like this. And inside the function, just call audio player pause car loop. Next, let's add the big explosion sound effect. Let's add a sound effect for lane change as well. The new high score sound effect we will add later. Alright, so let's test now. Let's add the button click sound effect to the Game Over pop-up as well. Next, let's add the new high score sound effect. But for that, first we need to declare a Boolean variable. Let's name it new high score. And set it to false when the race starts. Now, in the update score function, we need to check if new high score value is false and current score value is greater than the best score. Then, set new high score to true and play the new high score sound effect. Now, to test this, we need to reset the best score value stored in the shared object. The easiest way to reset it is to give the shared object a new path. Now, let's test. You can see here, the best score is currently set to 0. And when we score our first point, it played. Let's test it one more time. This time, it should play the sound effect when we get a score of 60. There you go. Next, let's implement the mute buttons for BGM and SFX. First, let's create two Boolean variables. These flags, BGM_muted and SFX_muted, will hold the current muted states of the background music and sound effects. Next, let's create getter and setter methods for both. Please note that we will store their values in the shared object, so the player's preferences are saved. So let's update the getter and setter methods accordingly. In the setter, we will set the BGM player mute value directly. And save it in the shared object. Now let's do the same for SFX_muted. Renaming it to SFX player. Next, we need to set the mute value for both players. In the lobby state, when the player touches the BGM sprite, the BGM_muted value should toggle. Similarly, touching the SFX sprite will toggle the SFX_muted value. Also, when the lobby loads, we need to set the BGM sprites and SFX sprites disabled property accordingly. That's it. Now let's test. Let's mute the BGM. SFX is still on. That's why we are able to hear the button click sound. Now let's mute SFX. See, we haven't set the mute value for the race state sound manager yet. So, in the race state, all we need to do is set the audio player's mute value equal to the SFX_muted value. Let's test again. See, the BGM and SFX are muted. That's because the app retrieved their values from the shared object, which were saved from the previous session. I don't want the game loop BGM to be this loud during the race. So, when the race starts, let's lower the volume of the game loop to 0.5. And when the Game Over pop-up appears, it should rise back to 1. Let's test again. It faded out. And it faded in. Let's test that one more time. Let's also add the button click sound effect to the leaderboard pop-ups closed button. Let's test that one last time. So, that's it. We have successfully implemented sound in our game. Next, we will work on creating a localization pop-up and adding localization support to our game. Let's open Starling Builder and create a new layout. By now, you should be familiar with Starling Builder and pop-up design, and there's nothing new in this pop-up that we haven't done before, so you can simply watch and follow along. Let's name this layout languages_UI. That's it. Our Select Language pop-up is now ready. And let's get back to VS Code. We need to create a new class. Let's name it Language Pop-up. This class will be similar to our leaderboard pop-up class, so let's copy a few lines of code from it. Just make sure we import the right class. Here, we need to mention the layout name. That is languages_UI. Also, we forgot to add the layout into the Asset Manager. Let's do that now. Now, in the lobby state, let's add an event listener for the info button. We need to declare an instance for the language pop-up. And instantiate it here. Then, use the pop-up manager to display the pop-up. Let's also add the button click sound effect to the info button. Let's test and see how the pop-up looks. Oops, there's an error. Oh, we forgot to add the main layout property to the language pop-up class. Let's do that now. Let's test again. Yeah, everything looks good. Let's implement the close button functionality. Next, we need to add an event listener for the main layout. It's a touch event listener. So, let's copy this portion of the code from the lobby state and paste it here. Now, if we check the main layout, we can see that it only contains 3 buttons. And each time a user interacts with the main layout, we need to know the name of the button that received the touch. Since main layout only contains buttons, we can confidently declare a local variable of type button, cast the even target as button, and assign it to it. To test this, let's trace the button's name. And you can see the button names being printed as we click them. Before we proceed any further, let's first set up the JSON file that will hold our localization data. Inside the Assets folder, there should already be a folder named Localization. Inside it, let's create a new file. Please note, We must name this file strings, and its extension must be .json. If the name or extension is different, the Starling Builder editor will not support it. Let's start by adding curly braces. These curly braces represent an empty JSON object, and all our localized texts will go inside it. Next, let's check which texts in our game need to be localized. Open Starling Builder and load the lobby layout. For our first example, let's pick the Start button. So let's consider the word Start. First, let's create a key called text_01, and its value will be an object that holds different translations. Inside it, we'll use keys like EN for English, FR for French, and DE for German. Each of these keys should have the localized text as their value. So let's add the translations for French and German. The good thing about the Starling Builder editor is that it supports localization out of the box. That is, it automatically reads the strings.json file from the localization folder and gives us the option to preview the localized texts directly inside the editor. Load the lobby layout. Then select the Start button and go to the Custom tab here. At the bottom, you'll find a field called Localize Key. Click on it and then select text_01. Immediately, you can see the change. It's currently showing the German version. That's because in the localization menu, the language keys are alphabetically sorted. To change the language, just select another one from the list. There is a character missing here. That's because we have not included it in our bitmap font. No worries, we will fix that later. Next, let's take the best score text. This one is a text field, so let's remove the number part from it. Save the layout and close the editor. I have already prepared its localized version, so I will just copy and paste it here. And its key will be text_02. Now let's open the Starling Builder again. Load the lobby layout. And select the best score text field. Then update its localized key to text_02. Save the layout. The rest of the texts are already converted, so I will copy and paste all of them into our JSON file. So in total, we have 14 texts in the game that support localization. Let's go through each one in Starling Builder and assign the correct localized key. Remember, changes made to the JSON file will only reflect after restarting the editor. The lobby layout only contains 2 texts that need localization. So let's move on to the next layout. This one has 4 texts. Let's assign their localization keys one by one. First, select the header text. Oh, we haven't named it yet. Let's rename it to header text. Wait, I forgot which key this one uses. Let's check it quickly. Yes, it should be text_05. You might have noticed, all the keys from the JSON file are populated in a drop-down under the localized key field. Next, we have the 3 buttons. Their keys are text_06, 07, and 08 in that order. This text field needs a bit of resizing to fit the localized text properly. And never forget to save the layout. This one doesn't have any text to localize. The next one has the header text, and its key should be text_09. The race layout has a single text, and the key for that is text_10. Next is the Game Over pop-up, and it contains 4 texts. That's it. We have now mapped all 14 localized keys to the text in the game. Now let's switch back to VS Code. And the first thing we need to do here is add the strings.json file to our asset manager. Just make sure the path to the file is mentioned correctly. Next, we need to declare a variable that will hold the current device's language key. Let's name it locale of type string. Next, let's generate its getter and setter. When the app loads, we want this locale variable to store the default device language code. To achieve that, in the getter function, let's use a utility class called capabilities. This class provides information about the device capabilities where our Flash application is running. The capabilities class has a property called language, which gives us the default device language code. If you haven't worked with app localization before, you might find this workflow a little unnecessary. But trust me, it will make perfect sense once we fully implement it. Next, let's declare a variable for localization. Let's name it localization. Set its type as iLocalization, which is an interface for localizing display objects, both in the Starling Builder editor and here in the project. Let's initialize it in the onComplete function of the asset manager because we need to fetch the string.json file from the asset manager. Also, note that we need to initialize it using the default localization class, which implements iLocalization. And into its constructor function, we need to pass 2 parameters. The first one is the JSON file, and we need to pass it as a JSON object. And the other one is our locale variable, which holds the default device language code. So, to pass strings.json file as a JSON object, let's use the asset manager's getObject method and simply pass the file name into it. And the other one is our locale variable. Next, we need to pass this localization variable into the UI Builder class as the 4th parameter. And when we call UI Builder's load method, it will automatically localize the texts. Now, this is enough if we only want to localize the texts based on the device language code at the app launch. But in our app, we have also given the option to change the language in the lobby state, so we need to handle that as well. This is where we are going to use the setter function of the locale variable. So, when the user opts to change the language, we also need to set the localization variable's locale property with the changed value. I think this is a good point to put a pause on our current work in the game class so that we can get back to the language pop-up class and finish off what we left out there earlier. Just to recap, we tested the select language pop-up and each button printed its name when clicked. In our strings.json file, we used EN for English, FR for French, and DE for German. Please note, these are standard ISO language codes used across devices. So instead of using full language names, let's replace the button names with these two-letter codes. This way, when a button is clicked, we can directly assign its name to the locale variable. Open Starling Builder and let's update the button names accordingly. Now, back in VS Code, let's set the locale value using the button name. So, upon clicking a button, the flow should be like, the pop-up should immediately close, and the text should update to the selected language. To close the pop-up, let's dispatch a triggered event on the close button, and its listener will call the onClose function. Okay, we're done with the language pop-up class. Let's return to the game class and continue from where we left off. Before we move any further, let me explain a few things. So we know that the option to change the language is available only in the lobby state. That means whenever the user switches the language, we only need to update the text in the lobby state. And we don't have to worry about the race state because there's no option to change the language there. So, in short, we need to make a couple of changes inside the lobby state. First, we will set up a variable to hold all the texts displayed in the lobby state. Next, we will create a public function to update those texts whenever the language is changed, and call it from this setter function of the locale variable in the game class. So, let's go to the lobby state. We need to make a few changes here. The UI Builder class has another method called load, which is similar to the create method, but instead of just returning the display object, it returns the entire UI data, including the associated metadata, as an object. So let's create a local variable called UI_data and call the UI Builder's load method. Its parameters will be the same as those of the create method. Next, to get the display object, simply assign UI_data.object as a sprite to main_sprite. Now, to access the associated metadata, which contains all the texts and their corresponding localization information that we set earlier in the Starling Builder editor. Let's first declare a variable, UI_params of type dictionary, and then assign UI_data.params to UI_params. Now, to update all the texts whenever the language changes, let's create a public function called localize. Inside this function, let's call the UI Builder's localize texts method, which takes two parameters, a display object that contains all the texts and a dictionary that contains all the associated metadata, which in our case should be main_sprite and UI_params. Now, back in the game class, all we need to do is, here in the setter function, we can consider the current underscore state always of type lobby. That's because we already know that the user can only change the language while in the lobby. And that too, only using the select language pop-up, which means there is no other place in the game or in the code where the locale variable's value can be set. So here, let's call the localize method of the lobby state to update all the texts. To be safe, let's also do a null check before calling the localize method. So that's it. Let's now test it and see how it works in the game. So, the default device language is English. Now, let's try changing it to French. Let's try German now. There is an issue with the best score text. The score is missing. Seems like we need to handle the best score text separately. Inside the race state, it's working. The game over pop-up is working fine too. Alright, now let's fix the best score text. Now, there are a couple of issues with the best score text. One is that we are hard-coding the label, which is not recommended when using localization, and the other one is that, after localizing, we are not appending the score value to the best score text. So, let's fix both. So, we don't need this hard-coded text here, because the same text is already defined in the layout, and when the lobby loads, the text will already be localized, so we just have to append the score to it. And now, we should do the same thing inside the localize function, right after calling the localized texts method. Or, just for the learning purpose, let me show you another way to handle this, which might come in handy in a different scenario. So the thing is, we can fetch a localized text directly from the UI Builder's localization property by simply passing the localized key, in this case, text_02. And then, append the best score value to it. Now, let's test it. Alright, so the best score text issue is now fixed. Now, what if our default device language is not English? Let's test that scenario once. To test that, let's comment out this line and instead, return French as the device language. Let's test that. See, it automatically localized all the text to French. Now, let's try the same for German. Hang on. Seems like we missed this text. Can't we localize it? We can, right? Let's do it. So let's open the strings.json file and add the 15th text. Let's add its translations. Now let's go to the leaderboard item renderer class. And here, inside this if condition, let's add. And get the localized text of key text_15. Alright, now let's test. So, that's complete now. And before we move on, let me quickly show you an issue that you might face with leaderboards when number of entries is high. So, in the leaderboard pop-up class, let's add more scores to the array. Duplicates are fine for this test, so let's just copy-paste. And let's test. Now, as we scroll, you will notice something. Multiple entries are highlighted, where only the current player's entry should be highlighted. This happens because, in a list component, item renderers are supposed to be reused for better performance. So, to fix this issue, all we have to do is add an else condition here in the item renderer class and handle the else case accordingly. This means we need to reset both the name text and score text colors back to the default values which were set in the editor. Let's copy this color for the name text. And this one for the score text. Let's test again. Perfect. Now only the current player's entry is correctly highlighted. Now, let's get back to the game class where we were testing the localization with the default device language. And we learned that if the device language is supported with localization, then the game automatically loads in that language. But what if the device language is not supported? Let's say it's in Spanish or Portuguese, for which we don't have localization right now. Then, let's test that scenario once and see what happens. Let's set it as Portuguese and test it. So, we can see that instead of the default texts, the localized keys are being displayed. And we definitely don't want that to happen. So, to fix this issue, let's first create an array and name it Supported Locales. And add all the supported languages to it. Now, in the getter function of the locale variable, let's check if device's default language exists in the supported locales array. If true, then proceed with that language. And if false, then we need to pick a fallback language. Since we used English for all the texts in the editor while designing the layouts, let's use English as the fallback. Also, I won't be able to test the else condition because my device's default language is English. So, to test this scenario, I need to try the Portuguese example again. Similarly, your device's default language might be different, so make changes accordingly. Also, let's add a trace statement here, just to confirm that our code is working. Now, let's test. As expected, English was picked correctly. And here in the debug console, we can see locale not found. So, let's revert that change. And we can remove this trace statement as well. Also, in the leaderboard pop-up class, we can remove the duplicate entries from the leaderboard array. Now, let's test the build one more time. So, we're almost done with the localization implementation. And the only thing left now is adding the missing characters into our bitmap font. Just keep in mind, if you're going to support multiple languages, make sure the font you pick actually supports all the characters. Otherwise, you'll start seeing these kinds of warnings in the debug logs. Luckily, our font already supports everything we need. So, let's go ahead and add those characters to the bitmap font next. This is our saved bitmap font configuration. So, let's open it up in the Snow bitmap font editor. Let's zoom in a little bit. Now, let's switch back to VS Code and copy this missing character. And just paste it here. Immediately, we can see it appear in the editor. Next, let's export this and extract it to a folder. Then, copy and replace the files inside our textures folder. Do we have more missing characters? No, looks like we're good. So, let's go ahead and test. Now, we can see the character here. Let's check other texts as well. Now, let's check for German. If you're not familiar with the language, it's actually quite difficult to notice which characters are missing. That's why we have to rely on the debug console. There's really no other way to catch the missing characters. Let's check the debug console. There you go. We have one more missing character. So let's copy the text and follow the same steps again. There you go again, the missing character. What? 2 more missing characters? Seems like it's from German. Again, let's repeat the same steps. Before that, let's first clean up this folder. And let's copy the other one as well. Here it is. Both of the missing characters came from the same select language pop-up. And hopefully, those were the last ones remaining. Let's once check the strings.json file just to make sure we have covered all the missing characters. This one we have included. This one too. And yes, so we have included all the 4 missing characters. So let's save this configuration. And let's replace it with the previous one. Alright, we are almost at the finish line with our game. And I can already hear you thinking, hey, how did we even make a Flash game without using a single movie clip? It's not like we built a vintage text-based game, right? There's a lot of movement going on, and we even have a cinematic blast in it. So, how on earth did we pull it off? That, my friend, is the magic of Starling Framework. And I'll be real honest, our game actually doesn't need a movie clip. But I don't want you to leave without knowing how they work. Because someday, you might want to convert your Flash games to Starling, or even want to start a new project in it. And not knowing much about movie clips would be a real bummer. So don't worry, our Starling bird is waiting to flap its wings. So roll up your sleeves even further, and let's learn how to bring a movie clip to life in Starling. Open Starling Builder and load the lobby layout. First, let's add a text field into the center layout. Now, from the strings.json file, let's find out its localized key. Let's enable these 2 properties. Now, from the Common tab, let's add starling.display.movieclip. Click on the drop-down and select bird_01. Let's remove the digits and keep the prefix as bird_. Click OK to load the movie clip. To preview the animation, just click Play here at the bottom. Now, let's rename the movie clip to _bird_MC. Save the layout, and let's get back to VS Code. Oops, I forgot to make one change. In the lobby state, let's declare a variable, _bird_MC of type movie clip. And it should be Starling's movie clip, not Flash's. The only difference is, in Starling, to animate a movie clip, we will have to add it to Starling's juggler, like this. By default, every movie clip's loop property will be true, and it will animate indefinitely. To play it only once, we have to set its loop property to false. You can see that the movie clip just played once and stopped. And if we want to take any action after the movie clip has played once, then we have to add an event listener. It will be event.complete. Let's add a trace statement here. Now, in the debug console, we can see bird movie clip complete. But what if we want the movie clip to play 5 times and then stop? All we need is a counter. First, let's declare a variable. We can remove this line because we want the movie clip to loop. Each time the movie clip completes a cycle, we'll increment the counter. And if the counter reaches 5, we stop the movie clip. To stop a movie clip, we can either remove it from the juggler or call its stop method. Please note that, besides stop, the movie clip class also has pause and play methods. Finally, put the trace statement inside the if condition to see when it stops. There you go, it stopped. Let's check the statement in the debug console. And that's it for the introduction to movie clips in Starling. Now let's safely remove all of these code and keep only what's required for our project. Let's test it for one last time and see if everything is working as expected. Next, how about we add a smoke trail particle effect for our player car? Wouldn't that be nice? Let's open the Stardust editor. And from the examples section, let's load rocket plus smoke trail. There are 2 emitters in this particle effect, but we only need one, the smoke trail. So, let's remove this emitter, which is for the rocket. And make the smoke trail active. We will have to tweak the color curve, but before that, in the Actions section, let's add a gravity acceleration field. And increase the Y gravity. We can also tweak the color of the smoke. Let's reduce the lifespan. The trail is too long, right? After all, ours is a car, not a rocket. Looks good for now, so let's save it. And rename it to Smoke. Close the editor and let's open VS Code. First, let's add the smoke particle effect into the asset manager. Next, let's create a new class. And copy-paste the whole code from the Blazing Fire class. And let's rename things accordingly. Now, in the race state, let's declare a new variable for the smoke particle. And instantiate it in the startRace function. We also need to add it to the main layout. Now, in the update function, let's set the smoke particle's XY position so it matches the player car. This way, it will look like a realistic exhaust trail, and when the car shifts lanes, it will move along with it. And when a collision takes place, it should be removed from the stage. Let's once test and see how it looks. We can see that the smoke particle is correctly placed at the bottom right of the player car. But the only issue is, it's sitting on top of the player car when it should be below it. So, to fix this, here let's use the addChild method instead, and make sure it's always below the player car. Let's test. Now, everything looks perfect. How about a camera shake effect on collision? That would look awesome, right? Let's make it happen. First, let's head to the Starling forum. It's a dedicated space for the Starling framework, where we can post issues and get help from the community. We can also search for existing topics and find discussions dating back to the early days of the framework. Let's search for camera shake. Here it is, exactly what we need. And guess what? It's the developer of the Starling framework, Daniel. He himself has shared the solution. So, we'll copy this code into our project. Create a new class called Animations and paste it in. Before using it, there are a few steps to follow. It says, don't forget to call this in the project startup code. Let's copy that line and add it here, right at the beginning of the game class's constructor. Next, Let's copy the one-liner that will shake our camera 3 times in 0.3 seconds, with an amplitude of 5 in the X direction. And let's add it to the race state, right where the collision takes place. Now, we don't have a camera in Starling, so we'll shake the entire race state to get a similar effect. So, let's replace object with this. And let's test. Not bad, but let's make it shake a little more. Let's double the amplitude. Yes, now it looks perfect. So now we have added both the smoke trail particle effect and the camera shake effect. Pretty cool, right? And honestly, if we keep going like this, there's a whole world of stuff we could add to our game, like braking sounds, car honks, skid marks, bonus points for near misses, and the list goes on and on. But hey, this is a tutorial, not a blockbuster game we're making. So let's put a pause on our exploration and start wrapping things up. Throughout the tutorial, you might have noticed some blurry or jagged graphics, and the text fields lacked crispness. That's because we need to tweak a few settings. You might have also noticed some performance hiccups while debugging the builds, so we'll tackle that as well. So next, let me show you how to fine-tune those settings to make everything look sharper and run more smoothly. Let's open our main class, TurboShift, and here we have the Starling instance. We need to set its support high resolutions property to true, which is essential for creating crisp and properly scaled graphics on modern high-resolution displays. Next, in the application descriptor XML, we need to add requested display resolution and set its value to high. It actually tells the operating system to provide high-resolution display data. And there you go, everything is now in high resolution. Do you see the difference? The text is much crisper now, right? Just look at that draw call count. We definitely need to tackle this next. Now, let's first understand why we're seeing high draw calls in our game. A draw call is simply an instruction sent to the graphics card to render something. The fewer draw calls, the better the performance. It's that simple. Here's the key. Starling can only batch objects together if they share the same texture atlas. Think of Starling like a delivery truck that can only load and deliver items from one warehouse at a time. If everything you need is in that same warehouse, the truck makes a single efficient trip. But if some items are stored in another warehouse, the truck has to go back and make a separate trip. That's exactly what happens when Starling switches between textures. It creates extra draw calls. For example, when your sprites use one atlas and text fields use another, Starling has no choice but to make 2 trips to the GPU. First trip, render sprites with texture A. Second trip, render text with texture B. That's 2 draw calls, right? But if we include the bitmap fonts texture inside the main texture atlas, suddenly everything is in one place. Starling can now batch them together in a single trip, one efficient draw call for both sprites and text. So the fix is simple. Add your bitmap fonts texture to the main atlas. So let's open the TexturePacker file, and let's add the bitmap fonts texture into it. Now, let's export it. Yes, it should replace the existing one. Now, back in VS Code. In the game class, this is our main texture atlas. And we can safely remove this bitmap fonts texture from the queue. And let's test. See, now the draw calls are low. Now, to really understand the difference, let's roll back the changes we just made and test again. Let's delete the bitmap fonts texture from it and export. So, when we open the leaderboard pop-up, the draw calls suddenly shoots up to 26. Now, let's add it back again. Now, once the bitmap font texture is part of the main atlas, the same leaderboard pop-up goes from 26 draw calls down to only 7. And finally, we got the game fully ready to ship, so congratulations! Before we wrap things up, let's play one round and go through all the features we have implemented, and from there, we will move on to building the AIR package. Hey, we got a new high score. So next, let's package our game as an AIR desktop application. For that, let's open this GitHub page and click on the link, Packaging an Adobe AIR Application. Here, we have AIR Desktop. Click on this link. Now, we need to specify the signing options in our ASConfig file. So, let's copy this portion and paste it inside the AIR Options section. First, let's rename our output file. Next, we need to specify the path to our certificate file. Before that, let's add the certificate file to our project folder. So, inside the project folder, let's add a new folder. Inside it, let's put the certificate file and set its path correctly. Next, we need to add icons. So let's copy this portion of the code and paste it here. Oh, we already have a file section. So let's copy only this part and add it here. Now we need to add these icons to our project folder. So again, let's add a new folder, name it Icons, and add the icons to it. If there are more icons, then we need to mention it here accordingly. Now, we are all set to package the app. And all we have to do is go to the terminal, then select Run Task. Now, select the folder, ActionScript. And then select Package Release Desktop Application, Shared Runtime. Here we have to enter the password of our certificate and press Enter. That's interesting. We got an error. Timestamp response not valid, huh? What does that even mean? Let's copy that and search for it in the AIR SDK's GitHub page. There is a dedicated repo, Adobe Runtime Support. Click on Issues. Then, let's search for the error. Look, somebody has already reported it. Let's go through it once. So we need to make a small change in our AS config file. Just add TSA with a value of none. Sometimes this could be a temporary issue, so if it builds without this change, you can go ahead and skip it. All right, let's try to build again. Enter the password again. And congratulations, build generated successfully. Let's check for the same in the bin folder. Here it is, turboshift.air. Let's install and see it in action. Oh, we forgot to disable the stats, and the icons did not load as well. Let's fix that. So, the reason why the icons didn't load, and we saw a generic default system icon instead, is because we forgot to reference their names in the application descriptor. We need to add an icon section to our application descriptor and specify the file names of the icon files for different sizes. Next, let's increment the patch version from 0 to 1. Please note that it's a good practice to update the app version even if we make a minor change in the application descriptor. Next, let's disable the stats in the main class. That's it. Now let's build again. Let's enter the password. And the update build is successfully generated. Let's install and see if the version is updated or not. And the version to be installed is 1.0.1. The stats are gone, and the app icons are showing up correctly. All right, with that, we've wrapped up the game development part of this tutorial. Up next, as promised earlier, I'll be showing you how to convert this ActionScript project into a Haxe project. And later, I will also show you how to publish it as an HTML5 game, which you can share with your friends to play. First, let's download and install Haxe. Like with ActionScript, I'm assuming you to have a beginner to intermediate level understanding of Haxe. If you are new to Haxe, no problem, you can still follow along. Though, there may be parts where you'll want to take a closer look or do a bit of extra reading to fully grasp what's happening. Next, open Command Prompt and type haxlib. The installation was successful, as we can see the available haxlib commands listed here. Next, let's set up haxlib. It will ask for a directory, where it should store all downloaded libraries. Let's press Enter and accept the default location. Next, let's install Haxe libraries we need for our project. The first one is OpenFL. Let's copy this command and paste it here. We can use the terminal even from within VS Code. There's no problem with that. Next, we have to run OpenFL setup. So let's copy this command. Seems like this installation is going to take a little while. So in the meantime, let me show you the extensions that we need to install in VS Code for the Haxe project. One is Haxe language support. The other one is Haxe extension pack. And the final one is Haxe blocks. Seems like we need to update haxlib. So let's do that. Now just type OpenFL to check if everything was installed and set up correctly. Yep, so that's done for now. Now we need to restart VS Code once. But before that, let's install one more extension called Lime, which provides project support for OpenFL. Now let's restart. Next, we need to install the Starling haxlib. After that, let's install Feathers UI. Next, let's install AS3HX. Oops, there is a typo. This library is required for converting our AS3 code to Haxe. And let's straight away convert our AS3 project to Haxe. For that, we need to run the command haxlib run AS3HX. Then, we should mention the path to our AS3 source folder, which will be the path to the SRC folder. Let's copy it and paste it here. Next, we need to mention the path of the source folder of our Haxe project. For that, we need to first create a Haxe project for it. So, open the command prompt. We will be adding the Haxe project folder to the desktop itself. If you want, you can change it to a different location. And let's use the command OpenFL, create Starling, project, and name the project TurboShift-Haxe. Next, let's change the directory to it, and open this folder in VS Code Editor. Now, we need to change the folder name, so let's rename this to SRC. And let's copy its path and paste it here and press Enter. The conversion is now complete. Keep in mind that this process does not provide a complete conversion, and a considerable amount of manual code changes will be required to compile a build. Next, let's check the VS Code window of our Haxe project to see the converted files. Next, let's install a couple more Haxe libraries. The first one is Format, and the second one is msignal. So we have now installed a bunch of Haxe libraries on our machine. But what if we have to add a new feature to one of them, or maybe we run into a bug that needs fixing, or handle some compatibility issues? Do we really have to sit around and wait for the library maintainers to release an update? The answer is a big no. In such situations, we can simply use the development folder instead. That is, instead of using the package version from HaxeLib, we download a local copy of the library's source code onto our machine and use it directly as the development folder. Since most Haxe libraries are open source, getting their source code is really easy. Once we have it, we are free to tweak the code however we like. Whether that's adding new features, patching bugs, or making it work with the latest versions without waiting for anyone else. So yes, for this project to work in Haxe, we'll need to make some changes in libraries like OpenFL, Starling, and Feathers UI. Don't worry, I've already made those changes and have shared the updated source code in my GitHub page. All you have to do is download those libraries from there and then link them to your project as development folders. Once that's done, your project will start using these modified versions instead of the default ones from HaxeLib. So let's go ahead and download them one by one. First, let's download Feathers UI. Before we extract anything, let's first create a folder on our machine where we can store all the Haxe library source code. Now, simply extract it to that folder. Wait a minute, let's rename it to HaxeDevLibs. Now let's copy its path. And back in VS Code, let's use the command haxelib dev, then name of the haxelib. In this case, it's Feathers UI-Starling. And then paste the path to its development folder and press enter. And we should get a message like development directory set to the path that we just copy-pasted. Now let's do the same thing for Starling. This folder name is unnecessarily long and confusing. Let's simplify it to Starling Haxe Main. Let's copy this link. And name of the haxelib is Starling. Done. Next, let's do the same for OpenFL. So that's done as well. Next, we need to set up the project XML. As we're only targeting HTML5 with this project, I've already prepared an XML file specifically for that. And let me copy and paste it here so that we can get everything set up quickly. Now, let's take a quick look at it. If you go through this XML, you'll see it contains all our project-related settings. First, we have the title, package, version number, etc. mentioned. Then, we have mentioned the main class, the output path, and the file name. After that, we have the window settings. Then we have mentioned the source paths, src, and code. Next, we have listed all the Haxe libs we will be using in this project. And finally, we have specified all the asset paths. One important thing to note, we will be using the exact same assets from our ActionScript project here as well, so no changes required there. So let's copy the asset folder from the ActionScript project to the Haxe project folder. Similarly, we also need to add a code folder here. Later, we will be adding the Haxe code for Starling Builder and the SoundAS library into it. That's it. Our project XML is ready. And we need to restart VS Code now. Wait. We have to rename the main class here to TurboShift. Alright, everything looks good, so let's go ahead and restart VS Code. We can see here, all the dependencies are properly mentioned. Of course, there will still be a lot of errors, and we will need to fix them one by one. Let's start by replacing all the Flash imports with OpenFL. We can see some errors related to Starling Builder. So let's add it to our project, and hopefully those errors will disappear. Now, extract it to a folder. From its src folder, let's copy this folder and add it to the code folder. Back to VS Code. Next, let's remove this metadata, as we have already mentioned the same in our project XML. Starling Builder related errors are still showing up, right? Also, there are errors related to feathers, which is strange. Oh yeah, that's because in ActionScript, we only have one version of Feathers UI, the Starling version. However, in Haxe, we have two options, the Starling version and the OpenFL version. For this project, we will be using the Starling version. So yeah, we need to replace all Feathers imports with feathers.starling. Also, we have not added the sound library to our project yet. That's why there are errors related to it as well. Let's try restarting the Haxe language server once and see if the errors get updated. Yeah, no, we only have feathers and sound library related errors. So let's go ahead and add the sound library to our project first. So, SoundAS in Haxe becomes SoundHX. Let's keep a note of that, as we might need to change this in our code as well. From its src folder, let's copy this folder and add it to the code folder. Let's try restarting the Haxe language server again. Oh, forgot to replace Feathers imports. Let's do that now. Before we restart the language server again, let's fix the other issues in the game class. This should be std.int. That's how we parse a float to integer in Haxe. We don't need the try catch here. Now, let's check the lobby class once. Now here's something important to understand. In ActionScript, we use dictionary to store key-value pairs. However, in Haxe, the equivalent is called map, but there's a key difference. Haxe is strongly typed, which means we need to specify exactly what types of data our map will store. So instead of just dictionary, we write map, then opening angle bracket, display object, comma, dynamic, then closing angle bracket. This tells Haxe that keys will be display object types and values can be any type. If you are new to Haxe, these angle brackets are called generics or type parameters. And the dynamic type is Haxe's way of saying this could be anything. Yeah, there's an issue in our main class, which we will fix next. But before that, let's restart the Haxe language server once. Yeah, we cannot use _root as a custom property name because the Haxe compiler uses it to refer to the root package. So let's rename it to something else like _root_ class to avoid this conflict. We've also referenced turboshift.root throughout the project, and now we need to replace it all with turboshift.root_ class. Let's restart the language server again. Next, we need to add Stardust Particles library to our project. Open the source folder, and let's copy these 3 folders and add them to the code folder. Again, we have to restart the language server. Here's another difference. In ActionScript, we could directly use starling.juggler, but in Haxe, we need to use starling.current.juggler. This is because Haxe version of Starling requires us to be more explicit about which Starling instance we're working with. So, we have to replace all instances of starling.juggler with starling.current.juggler. By now, you might be wondering why we have to restart the Haxe language server after each fix. That's because the language server sometimes doesn't automatically pick up all the changes we make, especially when we're doing bulk replacements or changing imports. By restarting it, we force it to reanalyze the entire project and give us updated error information. It's a bit of extra work, but it ensures we're seeing accurate errors rather than stale ones from before our fixes. Next, let's check the lobby class for errors. Here we are getting an error that says arrays of mixed types are only allowed if the type is forced to an array of type dynamic. In ActionScript, we could just pass an array and it would work fine. But Haxe is more strict about types and wants to know exactly what type of array we're passing. So let's add a type annotation. This will explicitly tell Haxe to treat this as an array of type dynamic. Our next error is missing super constructor call in player car class. You know what? Our player car class actually doesn't need a constructor, and we can safely remove it. But if you want to know how to fix this error instead, just add a super call inside the constructor. Next, we have an error with some parsing-related issue in the race class. Here, we actually don't require a parsing, and we can remove it if you want. But to show you how to fix it, just use std.int. Next, we have some issue in the game class. That's odd. There should not be any reference to OpenFL error in the game class. Seems like there is a reference to OpenFL error. Let's find out where. It's showing for Asset Manager's loadQ function, but why? Let's once remove this reference to OpenFL error and see where exactly it props up. There you go. This parameter should be of type string instead of type OpenFL error, same like ActionScript. Actually, there was no need for this conversion in Haxe. It's just one more example of why AS3HX is not perfect and needs manual intervention after the conversion process. Looks like all these remaining errors are just ripple effects from what we already fixed. So let's just ignore them for now and give the Haxe language server another restart. Perfect. No more errors. That's exactly what we wanted to see. Alright, now let's see if our game actually builds. Jump into the terminal window and let's run the command OpenFL test HTML5. We have some issues in the leaderboard item renderer class. Let's check that out. Always remember, Haxe is much more strict about type conversions than ActionScript. So, if we want to display a number as text, we need to explicitly tell Haxe to convert it using std.string. Here's a pro tip. If you want to avoid these conversion errors in the future, it's good practice to write your ActionScript code with strict typing from the start. Now, let's start debugging. Since we're debugging for the first time, we have to select a debugger. For HTML5 targets, we have to use Lime. And the launch.json file just got updated with that configuration. So from here on, every time we start debugging this project, VS Code will always use the Lime debugger. Now, we've tested the game thoroughly, there are no more bugs, and everything is working perfectly. So, we're all set to publish the game. First, we need to create a release build. For that, we have to use the command OpenFL build HTML5 -minify -terser. Please note that we are using minify and terser flags to optimize our game for web browsers as they compress and shrink the code size by removing unnecessary parts and making it load much faster for the players. Great! Our release build is now ready. Next, let's go to our project folder. We have set bin folder as the output path in our project XML. So let's open the bin folder, then the HTML5 folder, and again the bin folder. Now, we need to package all these files for distribution. So let's first select them all and then create a zip file. This will make it easy to upload to platforms like itch.io. Next, let's head over to itch.io and publish our game there. This is my itch.io account. If you don't have one, you'll need to create a new account. Head over to the dashboard and then click on Create New Project. Let's give it a title. And upload a cover image. Let's use the app icon itself. Next, in the kind of project, we have to select the HTML one. Pricing, let's leave it as it is. Now, here we have to upload the zip file we just created. And then select the option. This file will be played in the browser. Now, here we have to set the viewport dimensions. Frame options. Yes, it's mobile friendly. Orientation, portrait. Then, automatically start on page load. Then, genre. Let's select racing. No generative AI content in it. And that's it. Now, let's save and view the page. Hey, where's the full screen button? Let's go back once and check the settings. Oh, in the frame options, we need to select full screen button. Now save, and then view page. Now, let's try with a smaller viewport dimension. Yes, let's go with this size. Much better, right? Now, let's make it public and then save. Congratulations! Our game is now live. Let's try loading it in a different browser. And that's it, we're finally done. I know this was quite a marathon, 6 hours, but I hope you'll agree it was a valuable 6 hours well spent. What started as a Flash ActionScript project is now a modern HTML5 game, published and ready for the world. If you think this tutorial helped you modernize your ActionScript development workflow, please give it a thumbs up. Also, share it with other developers who might need it, and don't forget to subscribe for more tutorials like this. I'll see you again with a new tutorial soon. Thanks for watching and happy coding!